Hey, don't tell Mordillo. Well, what did you find that was funny? So, you know what? This manually managed sub count thing is gonna go away because I can't manage it manually. Too much work. Oh, okay. So, man, I'm so tired. I need caffeine in my system. So I don't know. Should I make up some tea? Put up some tea? Should I drink Coke? Both, maybe even. Maybe both. Yeah. Okay, I'll be right back. We're getting started anyway. Let me think. Did I announce my stuff everywhere that I needed to? I think so. Discord done. Social media done. Other Discord done. Yeah, that's it. Okay, I'll be right back. Hello, I'm back. So, hello X2, hello everybody else. Hello, hello, hello. Hey Johnny. On both YouTube and Twitch. So, as you can see, I'm sporting a new browser. I'm using Arc. What's funny is that the monitor that I'm using for my Mac is old and it's like falling apart. And so, for example, this area here that you see as uniform color, I know this because I have another preview on another monitor. This area here for me is like heavily textured. Like the LCD has, yeah, it has all kinds of noise going on in there. But in reality, that's not how it's supposed to be. It's just that it's a color that shows all the... Well, it shows that my LCD is like old. Are you liking Arc? I literally installed it like, I don't know, 2 hours ago. So I'm liking it for now, but you know, it's still very early. I'm noticing that my head covers YouTube chat a lot. Should we, maybe we should swap these two things around so that, you know, you can see Twitch chat in Bork anyway. So let's do that. I guess I have to pull this down here. Separate all tabs. Pull this one over this one. Yeah, add YouTube to Borg real quick. I've done this already. It's just that it's against the TOS. It's against the TOS to merge chat streams on both platforms. So, I don't know. Ziga secured my programming dry spell. I wasn't programming because I... Uh-oh. What are these freaking icons covering? Because I wasn't happy with Rust. Just use 2 Borg windows. Yeah, I could. How to define merge chats? Not really well. And you know what that means, right? It means that they reserve the right to be very liberal with that interpretation. So if they don't like it, they reserve the right to do something about it. And you mean for each chat message? We'll see. So, I need caffeine to get into my system. I am, you know what? I forgot the other day, but there were a couple of interesting content items that were posted that I also shared here that they were posted. I think I saw them on like Hacker News and similar stuff that were interesting. So one is this one. It's a I don't know. I defined it as an experience report, but basically a blog post about somebody at a company that was evaluating both Zig and Rust, and then some more Mozilla insanity. By the way, one of the reasons why I'm trying out this new browser is because of this news, and also because of seeing there was another news on Hacker News about Ladybird. Not that the Ladybird one or actually this one are really like changing my mind about things. They're just making me think about browsers more. That's all they're doing. So when are we making our own streaming platform? Good question. Although the economics of streaming become really, like, what we are experiencing right now is really different. It is really weird compared to the actual real economics. Like if you had to pay, for the bandwidth to run your stream, a lot of people wouldn't do it. Or if you did, you would have to monetize. Like you wouldn't have the luxury of being able to run a crappy stream, right? with just a handful of viewers. Like this one. Use our own computers for the servers. Yeah. So, well, let's take a look at these links. Arc, do it. Open in space 1. Oh, so you click a link somewhere else and it opens as a like a. Is this like a separate window? But it's it has a different layout, and then you can say open in space 1. Okay, so you can send it to your like main window. There might be a peer-to-peer streaming model. Yeah, but that also adds jankiness, right? And lag and you know what? What I'm saying is like just general suspicions that I have. I don't have enough experience, first-hand experience with peer-to-peer streaming to really know for sure. But it like you even having 40 people, I don't know. Should I message the Arc devs to watch your stream and give you tips? They are big Tuple fans. Oh, so you met all these people. You know all the Arc royalty. I'm doing fine for now. Like I haven't found anything that was completely, you know, counterintuitive. So there's a lot of new concepts that I well, that I need to learn, but that's it. So this article is pretty interesting. Let's see. At Redacted Company, we serve hundreds of millions of users. So, okay. I guess there's a claim about scale. It is annoying that they don't say, you know, what company that is. But in any case, we use C and C++ in some of our core systems, which end up servicing some of our most important features. For context, when this discussion started, there was about 100 lines of Zig at that point in the code base and a single service in Rust, an edge distributed API compiled to WASM. Throughout 2023, there was a discussion on Rust versus Zig and what to adopt based on our needs. Keep that in mind as Zig moves fast, and some of the arguments against it are already things of the past. To make it incredibly simple, our needs boil down to C interoperability, how easy it is to scale the code base with engineers, so hiring and maintaining. Spoiler, we ended up choosing Zig. I won't go too much into the details. I'm mostly sharing this because I think that it gives a great insight as to the kinds of considerations that take place in a company when your code must run on a huge variety of targets, and that might be run by hundreds of millions of users. I think the convo shows well that fast code or memory safety aren't the only factors to be considered. What follows is a little bit of an amalgamation of the discussion we had over the months. They do not reflect my own opinions. I was mostly following along these discussions and had already settled for Rust for my own team due to our specific needs. So this is somebody who does use Rust instead at the same company, but they are on a Rust team. Also, some of it is wrong or idealistic. Everyone in the convo either loved Rust, Zig, or both, and everyone wanted to make sure we made the right choice. I find this intro great because it really sets the stage and it tells you what kind of communication they're trying to do. So the limits of what they're going to say and their point. And their point is give you insight as the kind of considerations that take place in a company like theirs. And that's awesome. Like I feel like that this is awesome writing. You understand what your goal is well, and you're not trying to necessarily, you know, change or smooth maybe things that were said or opinions that were held, even if you believe they are wrong. So nice. I would say that this is a blog post that is useful both for Rust and Zig and other languages as well. In any case, the importance of C interop at the company in the specific company theme. The library we intended to rewrite had potential to be abused on every platform we are on. We are pretty much on every platform. Had potential to be used, not abused, to be used. So web, mobile, VR headsets, gaming consoles, or desktop. The only way to provide a C API is and use it is via sorry. The only way to guarantee that we run on all these platforms is to provide a C API and use it via FFI. Yes. So you compile it to offer a C API, import it from Swift, Go, Android, Kotlin, Java, whatever. Okay. We also had other libraries which we wanted to be able to glue and build together with the one we were aiming to rewrite. Nice. So main arguments in favor of Rust. Rust at the time was nearly 25 times more popular than Zig. I think right now it's still pretty... We're pretty far behind. But I think it's now Rust is like, if you look at stars, like let's assume that this is an estimate based on GitHub stars. We're now what, 4 times less popular, 5 times. So things have improved, I would say. If that was the metric and we went from 25 to 5. Any case, going by surveys and subreddits. Oh shit. Okay, so it wasn't GitHub stars. It was other surveys and subreddits. Okay. Well, given that we have abandoned the subreddit, I don't know. This, in some ways, might have gotten even worse. For people joining who don't know this yet, don't join the Zig subreddit on Reddit. It shouldn't exist. The only reason why it exists is because stupid fucking Reddit will give your subreddit to random people if you don't use it the way they wanted to use it. So if you remember a while ago, there was this bit of an uproar because Reddit was doing yet another shitty thing. And so Andrew wanted to abandon Reddit. I ended up abandoning it as well. Like, I didn't do it in the same time frame that he did, but at some point I did it as well. We wanted to delete the subreddit, or rather we kept it read only so that people could still access things that were said in the past. So we didn't even delete it. We just left it read only, but Reddit wasn't having it and gave the channel to a random guy, like somebody completely random just asked for the subreddit and was given it. So long story short, or rather fast forward, channel ownership change hands again to somebody else who now runs it, who can be trusted to run it. But yeah, it shouldn't exist. So join other communities. If you want a forum style community to join, go to zigit.dev. Go to zigit.dev. In any case. So Rust has been around in a stable state for much longer. This is an interesting perspective. Is it actually correct to state that it is stable state? And by the way, this as this person pointed out in the intro, these were the arguments. So people were arguing this. That doesn't necessarily mean that they are claiming that all these arguments are 100% factually correct. But is it even correct to say that Rust was in stable state? I mean, you do think of V1 as stable, but half of Rust is in nightly. But there's also the point that, yeah, stuff keeps changing, right? So Rust can... like, my impression is that Rust, with the V1 tag, is offering you retrocompatibility. It is offering you the ability to have your code keep compiling also when you update your Rust compiler version. So you update Rust compiler version, but your code doesn't break. But that's it. So how would you define stability then? V1 doesn't mean stability, does it? Well, I guess you could say maybe the compiler doesn't crash, the thing doesn't miscompile things at random, so fair. But Rust was doing well in that aspects also before hitting V1. And at the same time, I would imagine that it's not perfect either, as in... I'm sure that if you go on the Rust repository and you search for miscompilation, you will find some miscompilations, because some of those are not even up to them. It's like LLVM's fault. And similarly, Zig doesn't really miscompile things all that much. It's not perfect. There are miscompilations, but it's like... Anyway, sorry. Let's see. The Rust Foundation industry sponsorships was reassuring versus Zig's more uncertain setup. Oh yeah. Yeah, there you go. All the members that... all the Rust Foundation members. Let's go. There's one called Turbofish? Really? Turbofish is a team of developers building the next generation of open source blockchain. Oh, god damn it. It could have been anything. These people could have been working on any kind of problem. They could be... it had to be fucking crypto, of course. Oh, man. Oh, man. The Rust LSP was unequivocally loved by everyone who tested it. It holds your hand and it overall felt like an amazing experience. Nice. Cargo is an industry-leading package manager in terms of quality and dev experience. Memory safety and no undefined behaviors, obviously untrue, but that was the belief and part of the conversation we had to have. Then, if we're going through the trouble of moving away from C++, then it doesn't make sense to go halfway and still have potential memory errors and undefined behavior. Why not go all the way? CMD in Rust stdlib is available nightly. WASM support was just as smooth in Rust as in Zig. Rust and Zig were equivalent in performance for our needs. This is probably a point that that probably could even be revisited in any case. But in cases where Rust was faster, it was noted to be substantially faster. Benchmarks such as, oh yeah, this one. Yeah. Okay. C interoperable with Rust. One of the main arguments was that C interoperability matters a lot more for Zig, and it had nearly no ecosystem to speak of, whereas Rust had Rust first libraries for nearly everything we needed. Rust came along with great possibility for high-level Python bindings such as PyO3 and PyO3 async.io. Serving a few C bindings for Rust for some of our programs was argued to be inconsequential when the rewrite would take months anyway, and the benefits of using Rust would make the project easier to maintain for years to come. For Zig, easy to learn if you know C and C++ or even TypeScript. The language is a joy to write if you come from a C background. From a somewhat C background. Zig's compiler, it's also a C and C++ compiler, which means we can pull any dependency we need and build a CBI library for any platform we support. Very, very easy to support and target platforms. Zig makes it insanely simple to ship to consoles, mobile, web, desktop, etc. Zig targets was mentioned and beloved. Easy to write really fast software with native vector support for SIMD, no RAI, full-on memory management, etc. Zig works with debuggers. Our developers know out of the box. Which is interesting because it means that they're talking about debuggers that aren't LLD or GDB, because I believe Rust works equally as well with those guys. So they're talking about another debugger that might have more trouble with Rust. That seems interesting. In any case, the Zig build system is amazing and 100 times better than our makefiles. The ZSF is a 501c3. Let's go. Hey, Untangled. Thank you for the raid. Hello, everybody. Welcome. We are reading a blog post of a company that was evaluating Zig and C. Zig and Rust. But also with an eye towards the C interoperability. And so we were reading the arguments that were evaluated while they were making the decision. So what were you guys working on? I'll continue in the meantime. So these are implications on disclosing more or less of the financials of the foundation, with Zig being substantially more transparent. Yes, being a 501c3, well, the 501c6, I believe, has to also interesting. Oh, I see. His editor turns a C within parentheses into a copyright emoji Unicode symbol. This is just a C between parentheses. It just got transformed. In any case, if both 501c3s and 501c6s have to declare their financials, but it is also true that a 501c3, especially like I would say in general, but especially the ZSF, it's like, yes, our financials are going to towards paying developers. If you look at the financials of the Rust Foundation, let's just say that they don't pay developers. With all due respect, which in my opinion is not much due, to be honest. But anyway, this is an implication, blah, blah, blah. Okay, possible to port part of our C++ code base to the eventual Zig library and Zigify it later. An RTP protocol from scratch and go. Nice. 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 I want eventually to look into some real-time stuff myself as well in the future. I've been... A while ago, I needed a way to have people stream video for me, like when I was like inviting them on stream, because I started using Discord, and then I wanted to do something, you know, that I could... a different solution that I could control more. But then I found ninja so I started using that one, which is great, and that stopped me from looking more into it. I guess thankfully, because it's probably a huge rabbit hole. But eventually, I want to look into this stuff. So in conclusion, Zig significantly... oh, sorry, no, I skipped some. Did I? Yeah. 100% sure there won't be linking compiling issues against the targets we need to support. In conclusion, Zig significantly reduced the time and effort required to port our existing code bases and to ensure compatibility across all platforms. The team couldn't be convinced Rust would make it as simple. I did not go into a lot of the details, proof of concepts, and other things that happened in that period. All in all, it boiled down to one very passionate individual, and his choice will echo for decades and play a small part in the experience of what is most likely to be more than 1 billion unique users over time. I think that I found the most interesting thing that was in the things that ended up within the decision one way or the other weren't what we expected. So they were ease of learning and hiring played a much larger part than I thought it would, and it played in Zig's favor. Developer experience around the toolchain also played a massive part. The Z compiler and build system again tremendously helped it due to our needs and existing code bases. The ecosystem and community of Rust, along with the memory safety insurances, had less way impact than I imagined. What a story. Emojis in the financial section, so that's the real story. Man, Johnny. So all in all, that was interesting. Obviously, as the person said, all these arguments that were made in favor or against, you know, all the different trade-offs, these were opinions. Every single opinion, you know, you dive deeper and you could, you know, argue that it's not correct or not relevant enough. And there's probably, and similarly, behind these claims, there's like, for example, here, memory safety and no undefined behaviors. Obviously untrue, but that was the belief and part of the conversation we had to have. So, for example, people in the end evaluating memory safety for Rust and then deciding that it wasn't that important. It could be that they decided it wasn't all that important because the other things were super important. Or maybe they decided that it wasn't all that important because they were wrong. They underestimated the problem. Or it might even be that they thought it wasn't all that important correctly because we don't know what the problem space is, right? So it might even be that they know that the type of code that they write requires a ton of unsafe blocks anyway. And so you know, we don't have enough insight to really be able to judge if, you know, their decision making was correct or not. And obviously, you know, they know best what they want to do for themselves. But it is interesting. It is interesting that this was a concrete example of where, in the end, these arguments, when trying to match them against their reality, ended up favoring these things. To be fair, you know what? Let me show you. I think this article got on. It got on Hacker News. So let's go find it on Hacker News. What was it? Zig Rust work. The choice we made. So, yeah, it was this comment that I found kind of funny. So this feels very short-sighted to me. Again, you can't know. Like, unfortunately, I'm sorry. By the way, I'll tell you right up front. I don't think this is a particularly good comment. I just wanted to point it out because I found it funny, and I feel like it's like I don't want to dunk on just that one person. I don't know who they are. I don't care. But I feel like I read this kind of stuff all the time. Like, this feels very short-sighted. You don't know. You can't know. You don't know. Like, you don't know their problem. The blog post didn't give you even remotely enough context to know if their decision making at the end was right or wrong. You just cannot know, because it's trivial to imagine two different realities where either choice is the correct one by thinking about what the situation could be for all the things that were left unsaid in there, because a ton of things were left unsaid in there. So, and also there's some details that hint at them doing probably something like video games and something very complicated of that kind, where their need for things is very peculiar. Like the part where they say that Zig worked with the debuggers that they were used to, that probably hints at things. That hints at non-trivial things. And what's funny is that people here on Hacker News didn't really pick up on that, and they kept saying, wait, what are they talking about? Rust works with just as well with GCC and sorry, GDB, with GDB and LLDB. Yeah, it does. But that the person didn't say what debuggers those were, and probably they're different debuggers. So anyway, let's take a look at this. Easy to learn and easy to hire for, and an advantage for the first few weeks. That's that's another thing that's funny to say, considering that in our industry, developers change job every 2 years. I think that's I don't know if it's the actual average time before people change job, but I think they say it's at the very least kind of the optimal curve, right? People changing jobs every 2 years. That's how you maximize your pay raise. Let's see. Besides, we now have data indicating that ramp-up times in Rust is not longer than in other languages. Citation needed. Pretty big citation needed, my friend. On the other hand, serving millions of users with a language that isn't even V1 doesn't seem very reasonable. You don't know, man. You don't know. You don't know what they're doing. Like, let's say that it is, you know, it's like the stupid mobile games. Probably in good part is stupid mobile games. So they did mention VR headsets and stuff. So it's like, it's games. So what do you do with, like, what is, let's say that your stupid your stupid mobile game, like your stupid clicker game, like your Candy Crush game is not written with a V1 language. Is that unreasonable? You don't, man, you don't know. It's like, you just don't know. It's so annoying. Come on. The advantages of a language that is memory safe in practice and also heavily favor correctness, huge citation needed, in general boosts productivity tenfold in the long term. Oh man. I'm speaking from experience. I switched from C++ to Rust professionally, and I'm still not over how more productive and lovable the language in general is. Honestly, no citation needed. I'll trust you. Of course you have a better time switching away from C++. No doubt there. A language like Zig isn't bringing much to the table in comparison, in particular with user-hurting decisions around all warnings are errors, period. I don't know, man. You know, some could even argue that saying that all warnings are errors and you just don't have warnings that you are allowed to ignore could be something that favors correctness. But who am I to say? I'll go get one thing to eat and then I'll return. I'm not gonna read the so there's also the Mozilla blog post, but I'm not gonna read it. It's a shit show in any case. There's a there's a guy that had cancer that that was supposed to become CEO, and they what's the expression? They did him dirty, like a lot, real dirty. But we were talking with Ben Business about WebAssembly, and I had trouble wrapping my head around the WebAssembly component model. So I think we should, see, I'm getting something to eat, so I want to munch on something. And as I do that, maybe we could take a look at a WebAssembly component model video and see what are the amazing things that the WebAssembly component model is gonna allow us to do. Did they say hiring Zig devs is easier than Rust devs? Please hire me then. Hey, if only you knew what their company was doing, huh? But now that I think about it, game dev, mobile stuff, not necessarily, mobile games, the shitty ones. Maybe AAA mobile games as well. Do you ever try out flow control on macOS? Good question. I think I did, but it's been a while. I saw that you added a bunch of things. I'm actually curious to try it at some point. But also, let me see. Did you still have this bug? I need to make a bug report to Mitchell. As you can see, I think there's some math going wrong when emotes are involved in any case. Roblox, as far as I know, Roblox is a lot into Lua. So I think they have a stack that is more well-defined already. I don't know, though. I'm an outsider. I'll be right back. Okay, got my food. So, let's see what we can find about WebAssembly. There was that video that Ben didn't want me to watch, but I'm feeling rebellious, so I want to watch it anyway. Maybe. Right, that brings me to the music tab. That's unfortunate because. Yeah, I don't really want that to catch all my searches of YouTube every single time. Okay, let me see. So there's one short video. I think it is this one. Yeah. From the CNCF. Oh my god. My favorite. Like, they're my open source heroes, the CNCF. Theo saying that WebAssembly can't win. I never watched that video. I'm curious. Let's see what he has to say. So let's pause the music. Oh, I lost my music player controls here though. Okay. So pause this. Let's watch these first.
The horticulturally misguided
Okay, let me bump up the volume.
Algorithm. I know you're like, what? I just clicked a video about WebAssembly. Why am I reading about this? I promise it'll all make sense as we go forward, because tree shaking, WebAssembly.
What the heck is going on? What the heck is going on, man? I got hit by a spam of random follows. Oh, these look like totally legitimate users. Man, thank you all guys for following. Wasm co-creators say they are not trying to compete with Zig. Was that said in a video? Do you have like a link to it? I mean, I understand. How can I say? I believe it because I don't see how those things could be how can I say? Oh no, you cannot send links in Twitch in YouTube chat, man. Oh no, YouTube sucks. Okay, if it's a YouTube link, do you have a title to the, like, you can give me the video title. Sorry, I have a guess auto mod enabled that does stuff. Tell me what the title of the video is. Or the video ID. Oh man. Andrew, let's go. Introduction to Virgil. Oh, a new language by Wasm's co-creator. Okay, so this is about another programming language. That makes more sense because, like when you said Wasm co-creators says they are not trying to compete with Zig. Like you didn't say that they were working on a new programming language, and I didn't know that they were. So I was saying, wait, are they saying that Wasm doesn't compete with Zig, which is like fine? Fair, okay. So let's see. Introduction to Zig. Introduction to Virgil. Oh yeah. Turns out that Virgil also has to do with the Divine Comedy. Oh, it's an article. I see. I thought it was a video. Okay. On the new stack. Oh man. Okay. I came across a quote from the author of the language Virgil, who also happens to be the creator of a co-creator of WebAssembly. I'm not looking to compete with Zig. He said, having recently played the C with the C competitor Zig, I was interested to see what language was not competing with it. All right, this is an article from that same person about Zig. Yeah. Wait, when was this posted? I think is this an article that I should be aware of? I think so. Okay, in any case. Okay, it's a programming language from a co-creator. Okay. Okay, let's see why WebAssembly can't win according to Theo.
The JavaScript and the state of the browser, they're all a bit of a mess. This article from my quick skim seemed really cool, and I'm excited to dive in with y'all. Let's talk about tree shaking, looking up through the trough. But first, I need to talk about WebAssembly's dirty secret. Despite all of the hype, WebAssembly has had limited success on the web. Limited is putting it lightly. It's very rare we actually use WASM for anything other than like image and video processing online. Very few sites are using WASM to control what you see as you explore the site. There are very few sites where you click a button and then WASM deals with whatever is supposed to happen as a result. Incredibly rare. There is Photoshop, which does appear to be a real success. 5 years ago, there was Figma, though they don't talk much about the WASM stuff these days. There are quite a number of little NPM libraries that use WASM under the hood, usually compiled from C++ or Rust. I think Blazor probably gets used for a few in-house corporate apps, though I could be fooled by their marketing. You might recall the hype demos of 3D first-person shooter games with Unreal Engine, again, from 5 years ago. But that was the previous major release of Unreal, and was always experimental. The current Unreal 5 version does not support targeting WASM. I didn't actually know that, but I haven't seen any good Unreal demos in the browser in a long time, so it does make sense. Don't get me wrong, I think WebAssembly is great. It is having a fine success in the off-the-web environments, and I think it's going to be a key and growing part of the web platform. I suspect, though, that we're only just now getting past the trough of disillusionment. This is a classic, my favorite startup chart, where technology happens, we get really hyped, we realize the hype's not real, we crash, and then we slowly get to where things actually make sense. Very, very common. This is the experience running a startup. This is the experience learning a new technology. This is the experience doing basically anything hard that has any part that's fun. We're deep here in WASM right now. It's worth reflecting a bit on the nature of web's
I do think that there was a lot more hype about WASM before, which is interesting because there was a lot more noise about WASM at a time where you really couldn't do all that much with WASM. And now that you can start doing stuff with WASM because over time browsers added support for it, and it became better, and tool chains and programming languages started supporting it more. Now there's way less hype. I think it has to do probably more. I think it has to do less with the however you pronounce that word, of disillusionment. And I think it has to do more with company strategy. As in, I think that simply there was a moment where a lot of startups and a lot of marketing and hype was targeting WebAssembly. But then other things came along and kind of those companies also pivoted. Like, I remember all these companies that their product was, we do something, but it's WASM. And now you have companies that do something, but it's AI. So I feel like it's not really as much as the I would even say that WASM itself is not even done growing, right? There are more things being added to WebAssembly, and it will become more useful going forward. So I wouldn't even say that we are, in a sense, we haven't even achieved peak WASM hype when you start looking at it from a perspective of like the things that it can do. Like, I feel like it's not, you know, the original graph showed you one peak. I feel like it's like multimodal instead. Because some of it has to do with just other stuff taking over, like AI. When it comes to companies, because the thing is, companies being interested in this stuff, they make the content mill run. They produce conferences. They make stickers, they make plushes, they make noise about these things. They cause the new Stack articles to pop up. So I'm not sure, or let me put it this way. I'm not sure that we're done hyping WebAssembly. Yes, there was a peak. Yes, we're not that high anymore, but I think there's still some effort to hype it out. I don't think that we're at the point where now we're going to approximate its actual level of usefulness. I think somebody's going to try to hype it more still. It's just that they have a tougher time because a lot of attention moved elsewhere. And I think that what I'm saying will make more sense when we watch the stuff about web components.
WASM's successes and the failures as well. Take Photoshop as an example. I think we can say that WASM does very well at bringing large C++ programs to the web. I know that it took quite some work, but I understand the end result to be essentially the same source code, just compiled for a different target.
Yeah,
Similarly, for the JavaScript module case, WASM finds success in getting legacy C++ code onto the web, also as a way to write new web targeting Rust code. There are often tasks that JavaScript doesn't do very well at, or which need a shared implementation between client and server deployments. On the other hand, WASM has not been a web success for DOM-heavy apps. Nobody's talking about rewriting the front end of WordPress.com in WASM, for example. Depends on which communities you ask, although I will say it seems like that has stopped. We were definitely in a bit of a phase where people were pretending they could just rewrite their whole website in Rust and WASM. That's not a real thing anymore, and I'm happy we're over it. Why is that? It may sound like a silly question to you. WASM just isn't that good at that stuff. But why? If you dig down a bit, I think it's that the programming models are just too different. The web's primary programming model is JS, a language with dynamic typing and managed memory, whereas WASM 1.0 was about static typing and linear memory. Getting to the DOM from WASM was a hassle that was over. Oh
man. They're solving this. Like, we were talking about this stuff yesterday, right? I feel like some people at the WebAssembly, in some kind of WebAssembly meeting, agreed on this point, and now they want to move away from static typing, linear memory, and stuff. They want to make it funkier so that it's more appealing to people whose primary programming model is, let's say, JavaScript. WASM is really finding its footing in serverless/edge stuff and Docker replacement. OCI runtimes have support for running WASM in Kubernetes instead of a full Docker container. Yeah, but if you think about it for a moment, then do you really need WASM for that? Like, what you're telling me is that runtimes have support for running WASM in Kubernetes instead of a full Docker container. It's kind of like, yeah, like you can run also native executables, right? At that point in Kubernetes instead of having a full Docker container wrapping them. I'm not saying that WASM doesn't have any advantage. I'm just not sure. It's just like the advantages that you get might be so tiny that it's basically normal executables with extra steps. And that, by the way, what I just said also is, foreshadowing. I'm sorry. My point is that I'm not saying that what you're saying is wrong or not factually correct or like not a true, trend in the industry. I totally believe that, and I totally believe that these are improvements. I'm just saying that as an outsider who has the privileged perspective of looking at these things from the outside and not having to do this stuff myself, and just having a little bit of knowledge of how these things work, it's like this is like executables with extra steps. Like the hard truth is that all this tooling didn't really need containers in the first place. Like, you have all these systems that spin up a container. That's launching a process. The problem is that chances are that your application doesn't have a decent packaging story. You wrote it in a language that cannot create a static executable, and so maybe it's a bunch of Python scripts, and God knows how hard it is to get a Python environment to work correctly. So you know what you do? You wrap it all in a container. But ultimately, all this stuff, it's processes, it's executables and processes, just with extra, layers in the middle to solve at a wrong abstraction level a problem that you shouldn't have in the first place. It's hilarious, that kind of stuff. It's really hilarious. And you know what's super funny? Here's the... I'll tell you a secret. I'll tell you one secret thing that we do at the Z Software Foundation in the Z project. we have CI jobs that are really tough, like compiling the compiler, testing, running all the tests for all the targets that we have an emulator for. Takes a while. Want to know one huge trick that we use to make our CI runners more efficient? Drum roll. We run so we have self-hosted runners. So we have our own machines that run the GitHub Actions agent to run jobs. But here's what we do. We don't run that shit inside Docker containers. So not only we don't run it in Docker containers, so that you have less stuff going on, but also we purposely make the job runner stateful. You have things that can survive one run to the next. The run is not designed, like it doesn't expect the entire environment to be zeroed every single time it starts, which obviously it's a potential, like it's dangerous, it's Futgani. You ideally wouldn't want your, one CI job failure to influence subsequent CI jobs, of course. But you know how it's silly, right? Every single time you run a CI job, it starts, first thing it does, re-download 20 packages every single fucking time, like once a minute. It does it over and over and over and over and over. And then if you want to have something survive, you have to use caching. And GitHub cache, it's like slow as fuck. So what we do is instead, basically, there's a step where basically some kind of like pre-built tooling or something. It's something that you want to keep around, but also you want to occasionally update. And the CI job basically checks if it needs to update it by hitting an endpoint. And if it doesn't need to, it keeps using the same one. Otherwise, it does download the new one. And then it has the new one. And all subsequent runs can keep using the new one. So I'm not suggesting that this is a development methodology that you should adopt at your, random ass $ consultancy job where you make websites. Probably a bad idea. But it's hilarious that basically our secret trick is just doing normal things. It's just peeling away some of the abstractions that usually you get locked into. Like if you don't have your own self-hosted runners and you don't go through the trouble of seeing exactly how to make things work, then you're locked into these CI jobs that just can't have state. Which again, useful property in certain ways, annoying in some others. Let's see. There is no advantage to WASM over a statically linked single binary Docker container. I thought the issue with WASM on the web was that it is slow to communicate with the DOM. Is that not the case? It is. Well, the WASM doesn't communicate with the DOM, period. Like, communicating with DOM basically means that from WASM, you call a JavaScript callback. And that is slow for multiple reasons, including also annoyances related to strings. Because a string for you in WebAssembly is never going to be the same thing as a string for the browser. And so every single time you want to send a string from WebAssembly to the browser has to re-decode it, which is not the end of the world, but it's silly. And it's just like one of the many things that the browser has to do every single time you want to cross the WebAssembly boundary. A 100% is more steps. The containers, even base mean containers are more expensive than WASM. Yeah. Yeah. Oh, well, that from that perspective, sure. But then WASM is, but it's like Docker is to WASM what WASM is to native executables. Let's see, how do we solve the problem? I have no idea. I don't know. I don't use that shit. So I'm sorry. Every Linux process runs in a namespace and a C group. Docker containers have literally zero overhead, at least if they don't bring an entire second OS with them. But they do. They do oftentimes, no? Like whenever you have non-static executable that links another glibc or stuff like that. Like I can totally buy that. Like when everything is well designed, then it's not all that bad. But it opens the door to, like, it's designed, right, to basically taper over certain kinds of of problems, because you're basically, the solution is like, the problem is, oh no, I this thing is not portable because it depends on a specific version of libc, because on this OS the linker is in a weird ass place, etc. And so you use Docker containers to solve that problem, but the way they solve it is basically with overhead. So I can buy that the best case scenario is not all that bad. It's just, it's designed to, it's not, that's not the main use case, I suspect. Also, I believe the containers have virtualized network adapters, and I don't know how that, what that does. In any case, JS is UTF-16 and WASM is UTF-8. No, I don't think that's the case. I think, yes, JS, I believe, is usually UTF-16, but I'm not even sure. Like, I think the different implementations can hide whatever encoding they want behind an interface. So yes, JS, maybe, certain APIs are expected to speak UTF-16, but WASM is UTF-8 nothing. Like, WASM, you can represent a string in WASM however you want. So the thing is, even if you went through the trouble of encoding all your strings in UTF-16 in WASM, you would still have the browser need to look at your bytes and redecode them, like revalidate them, basically. Even if it's UTF-16 to UTF-16, the browser will need to check that string, because what it will be getting from WASM is, in any case, an array of bytes, like type-wise. So it needs to check if you have valid UTF-16 in there or not. So it's problematic. And the only way of fixing this is by having some other mechanism that is embedded in WASM that allows it to interface with an externally provided string. Kind of like, if you want to see this in like in a Ziggy way, it's kind of like being able to access UTF-16 strings from JavaScript as some kind of opaque type, that you have functions that you can call upon. Well, opaque pointer to be precise. It's annoying. Most Docker images are crap, but we were comparing WASM processes to regular native binaries. In that case, WASM is not the advantage. Better binary packaging is the advantage. Yeah, from my perspective, yes. Well, I don't know. Let's see what's going on. Let's see what else people are saying here.
Overcome only by the most ardent of the true WASM faithful. Relatedly, WASM has also not really been a success for languages that aren't like C or Rust. I am guessing that WordPress.com isn't.
Yes, understandably also. Like, man, I don't know. Do you want your WASM to be written in C#? In all honesty, you probably don't. Do you want it to be written in Java? Like, do you want a Java WASM thing? No, you don't.
Written mostly in C++. One of the sticking points for this class of language is that C#, for example, will want to ship with a garbage collector, and that it's annoying to have to do this. Check my article from March this year for more details. Interesting point I hadn't thought of. For C# to run in WASM, they have to write their own garbage collector in WASM, and now you're dealing.
Well, to be fair, C# is not the greatest example for this specific problem, because C# does have unmanaged C#. So you can write non-garbage collected C# if you really want to. And it's like, it's not very esoteric. I believe it's maybe not one of the main use cases, but I think it's a use case that it's well supported by the system. That said, the overall point still stands. And if we assume like the average C# programmer who doesn't know how to write unmanaged C#, because at that point that turns C# into a low-level programming language, then yeah, the problem exists. Yeah, either you know how to use a general-purpose programming language. Going back to what we were discussing yesterday, it's either you know how to use a general-purpose programming language, or if your programming language is not general-purpose enough, then WASM will be a problematic target for you.
Dealing with a gigantic bundle. Oh, apparently UE5 is back on the web now. Thank you for the correction from chat, Snow Squire. Appreciate you. Happily, this restriction is going away, as all browsers are going to ship support for reference types and garbage collection within the next few months. Chrome and Firefox.
Oh god, is this reference type something that still has to do with component model stuff? Is there another type of bloat that we have to think about?
Firefox have already shipped WASM garbage collection, and Safari shouldn't be far behind thanks to the efforts from my colleague Asumu Takikawa. Hopefully I got your name right. This is an extraordinarily exciting development that I think will kick off a whole nother Gartner hype cycle as more languages start to update their toolchains to support WASM. If you don't like my peaches, oh boy. This brings us to the meat of today's note. Web WASM will win where compilers create compact code. If your language's compiler toolchain can manage to produce useful WASM in a file that's less than a handful of over-the-wire kilobytes.
So namely, if your programming language is a general purpose programming language, then you're gonna do a good job. If your programming language isn't general purpose, then you're gonna create a shit WASM blob. Yeah. Trying to allow everything to target WASM is just silly. Oh boy. Dedev, do I have a video for you after this one?
You actually have a chance to win. If your compiler can't do that, you'll have to instead rely on hype and captured audiences for adoption, which...
Is PyScript Python on WASM? Yes, it is. Although I believe that they have two flavors of that. One is, and I think it's the main one, it's MicroPython on WASM. So the syntax looks like Python. The semantics are not exactly the same as Python. There is no Python interpreter running in your WASM. So it allows you to use Python-style syntax, but still write something that isn't as heavy as full-blown interpreted Python. So that means that there are certain weird things that you will not be able to do with MicroPython. But let's say that you instead are interested in pulling a random arbitrary Python dependency in WASM. You want to run Django in WASM or some other Python package that has, that makes good use of meta classes, reflection, some other kinds of metaprogramming, doing the weirdest runtime shit. So at that point, if you need a full-blown Python interpreter, then PyScript will compile the Python interpreter to WASM and run all of that inside the browser. So I saw one of the people working on it explain how it works, and they have like these two modes: MicroPython or full-blown interpreter,
which at best results in an unstable equilibrium until you figure out what's next. Whew, we're getting spicy here. I like this a lot. In the JS world, managing bloat in deliverable sizes is a huge industry. Yeah, we've spent so much time talking about bundlers. How many of my recent videos are arguably about bundlers? If we just go to my channel, where you can see I'm live right now, by the way, Corolling videos live. This one's about bundlers. We're at 1 so far. I was expecting this to be slightly worse, honestly. I talk about bundlers a lot. Package managers, kind of the same deal. We'll count that, so we're at 2. This one's about JS bundlers being rewritten from Go to Rust, so that counts for sure. We're at 3. Winter.js is different runtime, so I can't quite count it, even though it's competing with Bun, which is also a bundler. I talk about bundlers a lot, although I will make the point that my most recent bundler video kind of bombed, so it seems like the ecosystem might be burnt out on bundlers. We'll figure out what that means in the future. Anyways, bundlers like ESBuild are a ubiquitous part of the toolchain, compiling down a set of JS modules to a single file that should include only the functions and data types that are used in a program, and additionally applying domain-specific size squishing strategies, such as minification, which makes monikers more minuscule. So if you give something a big name, minification makes the name small. Good stuff. Let's focus on tree shaking. Yes, the thing that this article is supposedly actually about, even though the impact on WebAssembly is one of the most important pieces. So let's focus on tree shaking. The visual metaphor is that you write a bunch of code and you only need some of it for any given page. So you imagine a tree whose branches are the modules that you use and whose leaves are the individual definitions in that module. And then you violently shake the tree, probably killing it and also annoying any nested birds. The only thing that's left still attached is what is actually needed. I have a feeling after reading this guy's not going to like tree shaking too much, although a beautiful analogy. This isn't how trees work, though. Holding the trunk doesn't give you information as to which branches are somehow necessary for the tree's mission. It also primes your mind to look for the wrong fixed point, removing unneeded code instead of keeping only the necessary code. Interesting point. What does this link to? Fixed point and strike mandates. This is from over 10 years ago. This looks like a math thing. I'm not smart enough for that. I'm a JavaScript dev. But tree shaking's an evocative name, and so despite its horticultural and algorithmic inaccuracies, we'll stick to it. Fair. It's a fun name, even if it means nothing. The thing is that the maximal tree shaking for languages with a thicker runtime has not been a huge priority. Consider Go. According to the Golang wiki, the most trivial program compiled to WASM from Go is 2 megabytes.
Yeah.
That's just not tenable.
Well, that's because you have to pull in the entire Go ecosystem, the entire Go runtime, and there's nothing you can do about it. Go has a chunky boy runtime. You like Go routines, you like green threads, then you get the runtime. There's nothing you can do about it. So yeah.
And adding imports.
My God, micro Go? Are you serious? Is that a thing? Capsule? What? Web application framework. Oh, TinyGo. Oh, no, you're right. Yes, TinyGo. I actually knew about this. Then I forgot. Yeah, TinyGo. Oh, yeah, you're right. Yeah, TinyGo is the same idea. The core problem is your programming language isn't general purpose. So your programming language is not going to be good for you to program stuff like WebAssembly or embedded devices. So what do? But you like the syntax. You want to keep using the same syntax. So here's a language that isn't the same language. It looks like the other language, but it has different semantics and that are more general purpose. And that gives you TinyGo, MicroPython. And I mean, I guess that's reasonable. It's better than nothing. But man, it's kind of like just learn a general purpose programming language at that point.
Make this go to 10 megs or more. Or look at Pyodide, a Python WebAssembly port. The REPL example downloads about 20 megs of data. These are fine sizes for tech demos or, in the limit, very rich applications, but they aren't winners for web dev. This is a very important key I think people miss. If you're building rich applications that are heavily interactive, things like Photoshop or Figma, where there's a lot of graphical transformations and heavy math done in order to make the experience good, downloading a few megs of data to make that experience better is reasonable.
Yeah, but still, it doesn't matter, my man, because if you're building something like Photoshop, I promise you, you're not going to be able to pull off a decent Photoshop that runs in WebAssembly if you program it in Python, because of that problem, like the point is that if you're downloading 20 fucking megabytes for something simple, that's the level of bloat that you're getting yourself into. If you're making something like Photoshop in Python for WebAssembly, then you will have to download 200 megabytes at that point, and it will be slow as fuck, because that's what the language is. That's what the language does. So while this point here is, I mean, it's fair, but even then, Python is not going to work.
If this is the baseline for entry, writing your website for your blog in Go or Python is incredibly dumb. And it's a huge gap between the web that we use every day and the technologies that people are excited about for the web. Like, this gap is just so big in the expectations, the way browsers work, the size of these bundles, that it's hard to take anyone seriously who thinks the future.
By the way, talking about Blazor. Blazor is a disaster, in my opinion. I've seen Blazor pages take like 60 seconds to load. As in, you have the first load that shows you like an single color background, so it's not empty. There's something, just like one color and a progress bar, and then from the progress bar to the actual website takes like 30-40 seconds. It's absolutely insane. Also, people working with C# using the kind of things that, like, Blazor is kind of ASP.NET, but for the front end. And man, you don't want people that write ASP.NET to put their hands on front end code. With all due respect, there are a lot of insanely inefficient and bloated things that are done religiously done by people who write ASP.NET code. You don't want that in your front end. You actually, honestly, wouldn't even want that on your back end, but you don't get a choice. But man, you do not want that stuff in the front end. That like you're gonna turn phone batteries, instead of like lasting 8 hours, they're gonna start lasting 4 hours because you're gonna waste so many cycles on absolutely asinine C# ASP.NET behavior in your Blazor WebAssembly. It's dumb.
Future of the web is Rust. So let's shake a different tree. To be fair, both the built-in WASM support for Go and Pyodide ports of Python derive from the upstream toolchains, where producing small binaries is nice but not necessary. On a server, who cares how big the app is? Ooh boy, server component plug? I will say one of my favorite things about server components is the fact that I can just have giant code and not worry about it getting to the user, because only the parts the user is actually like rendering and consuming on client are shipped to them. Watch any of my server component videos to hear more about that. The one about airplane-proof code is a really good example of this. And indeed, when targeting smaller devices, we tend to see alternative implementations of the toolchain. For example, MicroPython or TinyGo. TinyGo has a WASM backend that can apparently go down to less than a kilobyte even. Interesting. Never heard of TinyGo. Interesting.
Yeah. Well, it's not Go.
Libraries used by the Go language tools alongside LLVM. We never started Go to be an embedded language, and so it got serious problems. Oh, Rob Pike. I love Rob's honesty. I just don't love his design decisions, his choices, his language, or much else about him. But at least he's honest, and that's a pretty great quote to admit that Go in embedded systems is terrible. Apparently, TinyGo actually keeps the...
Honestly, it's not even... I don't even see this as something to, I don't know, as a reflection to his design ideas. Not saying that necessarily Theo meant that, but we never expected Go to be an embedded language. It's like you can design a language that you don't design to really care about an embedded use case. It just so happened that at some point WebAssembly, which is not an embedded device, but it does kind of have similar constraints, coincidentally, became popular, and then people learn one language and they don't understand the importance of the general purposeness of a language, so they learn a language that isn't general purpose, and then they expect it to work everywhere. I would say the biggest problem here is that we as an industry don't understand this. We don't understand when a language is general purpose and when it's not, or like to what degree it is or it isn't general purpose. And this is a problem also, not just because, people don't learn the things that you shouldn't learn, but it's also a problem of all discourse around technology marketing. Like, I'm sure that the people who market Go have promised, the heavens to everybody who learned Go. Like, for every technology, you always get promised that it's going to be a silver bullet for every single problem out there. Case in point, Go at some point was being marketed as a systems level programming language. A lot of people thought of Go as something that is lower level than Java and C#. But it isn't. It absolutely is not. It's Go firmly sits in the Java, C# level of abstraction. So there was clearly something wrong, like a mistake by how Go was marketed. Similarly, I would argue that also Rust is sometimes marketed in the wrong way, because it is definitely more of a systems programming language than Go, no doubt there. But people also tend to think that Rust tackles things that it actually doesn't tackle. Whenever people conflate memory safety with correctness, this programming language cares about, not having memory safety issues, or you don't have concurrency issues in Rust. Well, that's not exactly true. You don't have, you don't have maybe problems where two threads corrupt memory by accessing it at the same time because of linear types. Great. but you still deadlock. You still super easily deadlock. Liveliness properties are not guaranteed at all by the language, and they're kind of pretty important for correctness. So, unfortunately, the problem is this. In our industry, we don't know exactly what's going on. There's a lot of very important aspects of computing that are just stuffy, boring, and not well explained to anybody, like the C low-level kind of stuff. Luckily, this is like, there's a renaissance there. But for a long time, a lot of people, including me, didn't want to touch that shit, understandably, because like the C tool chains are like a nightmare. But because of that, we lost connection. We lost our connection to reality. And then a bunch of asinine Silicon Valley marketing tried to convince everybody that, try this other, oh my God, look, there's this thing made up of 3 layers of abstraction that's slow and janky as fuck. So what did we do? We built a 4th layer on top. And guess what? That 4th layer makes it super fast and reliable. Boom. And people kept believing it. So we need to do better. We need to do better. And you know what? WebAssembly, all these issues that WebAssembly has, they are like, it's just facing reality. That's just the reality of computing and how our ecosystem is not ready to face those realities. I'm sure that there's people out there thinking that it's WebAssembly's fault that you can't program it from a Python application, and that needs to be fixed. Guess what? That's also foreshadowing. I'm actually tempted to cut short the video. You know what? Maybe I'll watch a little bit more, but like I want to watch the other one. You know what? Maybe we can watch the other one and then come back. Let's watch the other one and then come back, because this is so funny. Also, let me see what people were saying. Moving away from the .NET stack was the best liberating move of my programming career. So bleak, my university focused on the Microsoft stack. I am so sorry they did this to you. Yeah, it absolutely sucks. And to be fair though, had they gone with Java, like in my case, my university went with Java instead, it's not that much better. Actually, in many ways, C# is better than Java. The Microsoft ecosystem is mind-blowingly bad in so many ways. But if you just look at the language, I think that C# is a dramatically better language than Java. In any case, can vouch for everything Christoph just shared. I got to full team lead C# design patterns, clean code, freak to... Oh no! I don't miss it at all. Oh no! Were you doing dependency injection? Did you properly initialize all your DI containers? Was your code clean enough? Did you wash your code every morning before getting into the office? Oh man, otherwise, other people are gonna smell the code smells if you don't clean it every single day. Theo not liking Robpack is a strike against Theo, in my opinion. It's like a college student not liking one of the old masters. I think that the problem is that everybody who does like front-end type of stuff, they tend to have a lot of sensibility in terms of, certain type of nice things that you get from your language in terms of developer experience. And Go is, in my opinion, very clearly against that philosophy. It's like, no, you're like, yeah, that thing, that syntax looks cute. I don't care. You get the straightforward syntax, even if it doesn't look as cool. Or, oh, you want to do this fancy metaprogramming stuff? Yeah, no, you can't. You want to do metaprogramming? You do code generation manually. And I feel like the truth is clearly in neither extreme. Obviously, developer experience is not something that you should completely ignore, but it is also true that if you hyper focus on those superficial details, then you miss out on much more important points. Ultimately, I would argue that Go, in many ways, it's an ugly language, but it got right what really mattered. It really got right what really mattered, and a lot of people don't understand that. So whenever I hear somebody say that Go became popular just because of Google, it makes me laugh because, first of all, Dart is a thing. It's a Google thing. Nobody cares about Dart. The only thing keeping Dart alive is what I don't even remember what's it called. Well, their GUI thing, and otherwise Dart would have died already. And on the other hand, Go fixed a lot of problems that exist in Java and C#, and it was Flutter. Thank you. And it was a dramatically better alternative than them in many ways. So yeah, it's fine. It's fine. I personally like Go. Honestly, going back to Go from Zig, every single time I've done that, like going back to Go from Zig, kind of painful, man. It's been kind of painful. You lose so many good things from Zig, but I like it. Go is on the same level as Lua, in my opinion. Go and Rust, I'm not sure, because the thing is, Lua runs in its own interpreter. Sure, Lua is not a low-level programming language, but I think Lua is much more embeddable than Go. Like, I think that, you know how you have games that have all the scripting being running in Lua, in a tiny Lua VM? I don't think they would be able to pull off the same thing with Go. So I would say that Lua is a little bit of a... It's a bit, sui generis, as the Latin used to say. Like, it's kind of its own thing. It's a bit different. In my opinion, Go is best compared against Java and C#. Go is lower level than interpreted things like Java, JS, Python, but higher level than C and Zig. Just having GC doesn't mean it's high level as being fully interpreted. Go doesn't just have a GC. Go also has, for example, runtime type information, just like Java does. Also, I think that these guys can also be, JITted if you want, and like run in like a more native fashion. So from my perspective, Go compares to these guys. Well, not even exactly these guys. My list has Java and C# on it because those are tools that solve the same kind of problems. Like, you're doing web services like backends, you can do them in Java and C# as like these leading technologies used by let's say enterprise software development, or you can use Go. And and that's where they kind of shine. Like, I would say that Go shines doing web dev stuff, and you can see that also in how their standard library is structured, for example. Using Tomcat row. Oh no. Let's see. My idea of using Zig with WASM is separating computation-heavy code to be handled by Zig, compiling into WASI, which runs process on the client side. Does this bring benefits by using both Zig and WASM? Which runs process on the client side. Like, if you're doing WASI, it means that you're not running this stuff in the browser. Like, so I guess the question is, why are you... So if you're using WASI, why are you not just running native Zig on the client side? Why are you going through WASM plus WASI? And by the way, you might have reasons. I'm not saying that there aren't. I'm just trying to understand what your, use case is. Why Borg moves when in detached state? Bugs. 100% bugs. The trick is to ask people to expand on what they mean by cleaner. No, that doesn't work. Like, if you find people who truly believe in cleaner code, they're not gonna be able to give you like an answer that you can make sense of. They're gonna give you bullshit answers that they strongly believe in. So there's no trick. You know what the trick is? When you have when you are in a workplace where everybody believes in clean code, you leave. That's the trick. That's the one trick that works 100% of the time. It's the only one. One potential benefit of using WASM components: distributed development teams don't need to have access to the entire code base. Okay, we'll see about that in a moment. Using Go for many years for work, but it's like the more recent decisions that they are making. Me too. I'm really sussed out by what they're doing with generics. No. It wasn't me. It was a bug, 100%. How does Swift compare? I would say that Swift is also in the same general space as Java, C#, and Go. But, you know, it's like you have C# and Java that basically exist in this space where you do develop enterprise-style software development with getters and setters and a ton of interfaces and OOP chains and containers and what the fuck not. And you care about DDD, that kind of thing. Then you have Go, which exists in roughly the same space, but it locks you out of certain kinds of enterprise software development insanity because it doesn't allow you to go all the way 100% with weird ass abstractions. So you can't make easily. It's not idiomatic to make factories in Go, or at least it used to. Now they have generics. Now they're introducing iterator protocols. So God knows what's going to happen. But they used to be at around the same space. Swift is another language that gives you roughly the same tools, or at least, you know, I'm referring to Swift like version 3.4. They added a bunch of weird shit after that I don't know, does more stuff. So I'm not commenting on that specifically. Like Swift UI, I understand. I don't know exactly what Swift UI did to the language. I know it did bad things to it. But the point is, it's kind of roughly in the same space. The problem, though, is that Swift doesn't run well on anything that isn't macOS. That isn't Apple. So macOS, iOS, that kind of stuff. So Swift, unfortunately, it's kind of... I didn't mention Swift because you just don't write server-side stuff with Swift. In theory, you could. They are telling people that it is possible, but I don't know if you saw the recent blog post that tried to use like Swift at the WWDC. Apple announced that Swift now has a kit for developing fully static applications. So to compile a static executable out of compile a Swift application as a static executable so that you can run it on Linux, like Alpine Linux. And a fully static Swift executable today weighs 100 megabytes. So let's just say that they are, even in the best case scenario, just right now getting started with supporting that part of the ecosystem. So anything that isn't controlled by Apple. But I would say that in spirit is in that same space. I would even say that Swift, in many ways, it's a super fancy C#. Like it's fancier than C#, it's fancier than Java. Anyway, like I feel like it has similar features, but they are pulled off in a better way in many cases. That's my impression. Swift has reference counting but doesn't have stoppable word GC. Oh yeah, there's also that. That's another peculiarity of Swift. In an office-friendly way, it exposes their lack of thought and that they're just using clean because they haven't done that thinking. I find all languages either stop languages development or live long enough to become C++. Right? Either you die a hero or you live long enough to become C++. But you know what? There's a solution. Whatever problems you mentioned in this discussion, there's one solution that will solve all these problems. Whatever those problems are. Like, I don't know, maybe I missed a message. Somebody said that they are trying to lose weight. Guess what? WebAssembly component model is going to fix that.
Evolution of WebAssembly, the component model. My name is Sohan Maheshwar and I'm a lead developer advocate at Fermion. So I'm going to start off with maybe some with a statement that could be a little controversial, which is it's really time to reboot software development. And the way we have been building and architecting software all this while has been based on certain assumptions. And now with the next evolution of WebAssembly, these assumptions will change. So really it is time for us to reboot software development. Let me give you an example, right? And this example is called the 2,400 hour problem.
What does a developer advocate role entails? Oh man. Let me see also on YouTube. Where's my YouTube chat? Hi Crow. Hello. You can use my name. You don't need to use my surname. Loris is fine. I sent you a DM on X asking about how to use Zig to program an STM32. Any advice on that? I don't have any specific first-hand advice that I can give you because I myself I'm not super knowledgeable of embedded development. I only know how to program the software you can love badge that Matt made. But what I can suggest to you is to check out the Zig embedded group, because MicroZig, we have a hardware abstraction layer library, so a library that basically collects all the schematics information from hardware producers and basically prepares a bunch of like type definitions specific to whatever CPU or board you want to use. So it's called MicroZig, but it's not a different language. It's just a framework. Like it's just a library for Zig. So MicroZig, in theory, should have support for your architecture, and more specifically, join their Discord server. They have a Discord server, and join it. It is actively used by them, and ask for help, and they will be able to give you pointers. So that is my suggestion. Alternatively, if you really don't like Discord and you want something different, you can do this. Let me see how to. Oh, okay. You can go to zigit.dev. Zigit.dev is like a forum style community, so you can chat with people and ask these kind of questions in a setting that isn't like instant messaging in case you don't like it. That said, Discord is probably the shortest path for you to know what to do with MicroZig in case that the README isn't, clear enough in on itself. So let's see. What does a developer advocate role does? A developer advocate is somebody that works basically in marketing. Developer advocacy doesn't necessarily always live under marketing. It can live under other branches of the company, and as a form of marketing is peculiar. So don't immediately think that a developer advocate wants your email address to sell you shit, which is more likely that a random marketer would want to do. But developer advocacy, it's basically I used to work as a developer advocate at Redis Labs, and my job was to basically teach people how to use Redis more efficiently. So, for example, I discovered Zig because with Redis, this is funny. We were talking about WebAssembly. With Redis, it's not WebAssembly, but it's like close enough. Redis is like a caching system / database. And what's interesting about Redis is that it has custom data structures. Like you have all these data structures that have very specific properties in terms of like, efficiency of operations. And but you can add custom ones. And what's interesting is that other databases tend to emulate the semantics of a given data structure on top of like a key value store oftentimes. So like you have stuff like FoundationDB where they have layers, so abstraction layers. Well, they're like literally called layers, but they are also factually abstraction layers. They basically give you, object like document store semantics, but it's still implemented off top of key value pairs in the database. That's not how it works in Redis. In Redis, if something is a linked list, it is literally implemented as a linked list in the machine code. So like imagine a C implementation of a linked list. If something is a set implemented using, certain type of tree or a hash map, that's exactly what it is. And so if you want custom data structures, you can make your own custom data structures. So for example, I made a cuckoo filter implementation for Redis. a long time ago. And by the way, and how do you do that? The way you can add new data structures to your Redis is using the Redis module API, where you build your new data structure as a dynamic library, so as a Windows DLL, or, well, Redis doesn't support Windows, so scratch that, as a SO file on Linux or a .dylib on macOS, and then you put a path to it in your Redis config, and boom, Redis will load your data structures at runtime, and now you will be able to use it. And as I said, it will run your exact machine code, like your implementation will run. So it's not just you're getting, the syntax sugar. No, you're getting the exact characteristics that you would want from that data structure. Problem is, how do you write dynamic libraries? Kind of the same type of problems that you have with WebAssembly. You cannot do that in Python, or God forbids, were you able to do that in Python, you wouldn't want to have freaking Python running in your Redis database. So that's how I discovered Zig. In the end, I got involved in the Zig Software Foundation and the Zig project because of doing that. So developer advocacy, it's kind of like this. They write tutorials, they talk to people about what they do with a company's product. They teach people how to be more effective with it. And ultimately, you could say, marketing isn't necessarily just feeding you lies. Good marketing is also just informing you of true things. There's not a lot of good marketing out there, if we want to be fair. But if you want to really expand your understanding of what marketing is, let me tell you that let me think of a project that we might want to take a look at. Let me tell you that, for example, let's do 3-seater. Let's go to where's the GitHub repository? Come on, man. No, I don't want language bindings. I want the thing itself. Okay. The reality is that even a README is marketing. Whenever you're writing a README for something that you made yourself, you are doing marketing work. And this is also the type of marketing work that is closest to what developer advocates do. But setting that aside, it is marketing at its core. You are basically recapping, digesting information for the reader to give them an overview that prioritizes what is most important. Because if you don't do this, the alternative is that people have to read the source code. And people don't want to read the source code. People want to hop on your project, hope that the name is explicit enough, and then if there are any questions left unanswered, which is usually the case after reading the title, then they want the README to answer those questions. And only after they reach a critical level of interest in your thing, then they will be interested in diving into the code, even though the code is the actual source of truth. So we all consume marketing materials. We produce and consume marketing materials ourselves, and it's not bad. It's actually good. Like README files are good. Like imagine a world where somehow you're not allowed to have a README file. Not just not just something that is recognized by sites like GitHub and gets displayed in a preferential way. Like it gets its own space in the root of your repository. But no, imagine like you're absolutely not allowed to write any kind of recap of what your thing is about. Things would be really hard in comparison. So that's what marketing is at its core. So that's why roles of marketing exist. They make sense. A lot of money is spent on marketing, and also developer advocacy is a thing. That said, there's obviously also the dark side of marketing. The dark side of marketing is that when I worked at Redis Labs, for example, I ended up working at Redis Labs because I was generally a fan of Redis, and I liked the way Redis worked, and I had worked myself with using it, and I had my opinions on what to do with it, what not to do with it, how to use it, how not to use it. And for example, one thing that I strongly believe about Redis is that I like the model for transactions in Redis. Long story short, Redis can do transactions, but it cannot do transaction rollbacks. So if you think of a Redis transaction, the same way you think of a SQL transaction, you will be extremely disappointed when you cannot roll it back. But the thing is, it is a transaction. Well, it's called a transaction in Redis, but the semantics are very different. And if you change your mental model about how to use that tool, then you can use it to great success. Problem is, at Redis Labs, a lot of companies that were interested in buying Redis, or rather, a lot of people that were in sales at Redis Labs that were trying to sell Redis enterprise licenses, we are talking with big financial intermediaries or people who are basically trying to upgrade from their SQL databases to some NoSQL model. And all these people reasoned in SQL transactions. And the salespeople weren't super technical people. And so it's not like they could really have brought up all the technical arguments to push back against that view. Or even if they did, you still have the problem that you don't want to. It's kind of like what I said earlier, right? If you're in a workplace with like a bunch of clean code nut jobs, like it doesn't matter. You're not going to be able to change all their minds. It's like they're insane, and your best option is to leave. But if you're selling a database, you don't want to leave. You just want to make the sale. So long story short, for example, I wrote a blog post where I explained my perspective of why, in my opinion, Redis transactions are okay the way they are. And you just need to understand that you cannot use them the same way you use SQL transactions. You have no idea how much internal pushback I received for that blog post. A lot of people were angry with me. So I'm dumb enough to focus on the technology and not give a fuck about company politics. But other people are smarter than me. Other people will join a company and they will do what it is necessary for them to get a better salary, get a better position, get more stock options, and grow in the company. Because ultimately, the company wants to sell more of that thing so that it's a startup, so that they can get a public offering or get bought by Microsoft or whatever. So those people also land in marketing and in developer advocacy jobs, and they will tell you what you want to hear. So there's also a lot of very shitty developer advocacy that's happening, just like there's a lot of shitty marketing that's happening. And what did I want to say last? Well, and ultimately, you need to be aware of this. You need to be aware that a lot of material out there is done by developer advocacy style people. So, and it's not like they're going to lie to you. It's not like people are going to be, coy about them being developer advocates. It's a job, and it's up to you to decide if you think what they're saying is valuable or not. That said, it is also true that, there's a company, there's an economic interest behind these things. When a developer advocate is giving a talk at a conference, who paid for the flight and their hotel is the company. And the company ultimately will want to get a return of investment. So, for example, this person here is going to give us an explanation on the component model. It's up to us to judge if that explanation is going to be good or not. And at the same time, though, you can probably bet that they will have a overall optimistic outlook on the feature, because chances are that, where is it? That Fermion probably deals in WebAssembly, and they probably also wouldn't mind to have better interoperability. So let's take a look at what Fermion does. Denser cloud compute on Kubernetes and beyond. Run your apps with 50x or greater workload density per node, dramatically increasing capacity and reducing costs. Don't tell me. They're doing the usual distributed Kubernetes kind of shit, but instead of containers, they're using WebAssembly. I'm just guessing. Actually, does anybody know what Fermion does? I have no idea. This is like my first time taking a look at what they do. Create, build, test, and deploy app in just a few minutes. Spin new. HTTP.js. Okay, so this is JavaScript, so it's not just WebAssembly. I think they have a WASM runtime. Yeah, right, of course they do. Spin up the developer tool for building WebAssembly microservices and web applications. Oh, Spin is the developer tool. Okay, do more, faster. Pick your favorite language and dive into the important part of using Spin's serverless framework. Choose your language. Spin's SDK are available in Python, Go, JavaScript, Rust, Go, and .NET. All WASI-compatible languages are supported. All WASI-compatible languages are supported. Well, the thing that I don't understand is, wait, since when is JavaScript a WebAssembly language? I don't get it. You don't write WebAssembly applications with JavaScript, right? Well, in any case, you know, that they're in this space. And so that's why they're paying somebody to talk about this kind of stuff. And of course, this is where you start to be careful about. AWS Lambda takes 250 milliseconds. Fermion Spin takes 52 milliseconds. Hello, Supersonic. Goodbye, cold starts. Fermion Zig's router repo. Interesting. Let's see. So that's your Zig origin story? Yeah, pretty much is. If I deploy a web server written in Zig, everything is considered SSR until I add WASM that can do client-side rendering. And the idea is to offload processing on the client side to offset server load. Oh, okay. Sorry. Right. This is your explanation on what you were trying to do. I see. I have no idea. I can see how your setup could make sense. Potentially. I guess it's up to you to evaluate if the extra complexity of this system is going to pull its weight, but I'm sure you can do that work. And I'm not going to be able to give you a better estimate as an external observer who doesn't know the details. I will check ziggy.dev because the microzig Discord seems to be not really active. I've used it before. I know that there is some activity. Maybe, you know, there are periods where they're more or less active, but microzig is being actively developed. That's for sure. Can you explain this? Learn by doing project really means any tips? Well, what? It means that instead of just watching like a course or something, you try to do the thing, and hopefully that teaches you something, I guess. Okay, let's no, not this one. Let's watch this one. Okay.
Basically, parsing a URL or a URI is
right. Let's parse a URL.
It is a non-trivial task. It is fairly simple.
Yes.
You have a URL like this that looks like HTTPS.
Well, it's actually not all that simple. You have to write a spec-compliant URL parser, and there's a bunch of stuff. Like, it's not terrible, but it's not immediately trivial either. Anyway.
//www.fermion.com/blog. And this has a protocol, it has a host, and it has a path name. And sometimes it could have some queries after it as well. Parsing this is straightforward. Right? And every single programming language out there has its own or multiple URL parsers that are standards as libraries that are used. Now here's the thing, C++ has one, Java has one, JavaScript has one, Rust has one, if not many. And it estimates, rather we have estimated that it's taken at least 2,400 person hours to actually construct all of these parsers from scratch. Each language needs its own, each framework needs its own. Why couldn't we just use a single parser that was created as a specification?
Yeah, you can. You write it in C, and then you use the C implementation, just like people are doing all the time. I don't know if people do that with URLs specifically, but like you're parsing Markdown, you can pull, him. Look, it's not him. It's not him. It's the WebAssembly. What's it called? The WASM Foundation, the WASM Alliance. It's the WebAssembly Alliance that is reinventing libraries, I guess. But yeah, like I want when I want to reuse effort, I in my static site generator, I depend on the Goldmark Markdown parser, which is written in C, and boom, yes, I don't have to make my own. That is already solved. Yeah, by using C APIs, well, C ABI, that kind of stuff. But I'm looking forward to see the new and improved way that WASM wants me to do things now.
Well, the problem is there are so many different languages out there and each of them need their own parsers. Apply the same thing for other specifications, cryptographic keys, all of these computing things that really have specifications but need to be implemented from time to time in every language and framework there is.
No, they don't. You just use the reference implementation. What do you mean? Okay. Well, let's continue.
Well, all of this is going to change with something called the component model. So really in the future, if you're building a JavaScript app, you can say something like, I need a YAML parser. And you can actually grab a YAML parser that is written in Rust because Rust is good at doing things like parsing since it is a low-level language. Similarly, you can say like, I need a date formatter, and you can use a Python library because Python's good with numbers to really do that. And all of this in
Python is good with numbers, and so you use a Python date formatter?
your JavaScript app. How this is going to work? Well, that's what I'm here to tell you. To understand how the component model works in WebAssembly, you need to know a bit about WebAssembly. And the boring answer about what WebAssembly is it is another portable bytecode format, which means that it can run anywhere.
Well, that's actually, what do you mean? That's the factually correct and thus interesting answer. Anyway, sorry.
As long as there is a runtime for it. Now, this was originally developed for the web in the mid-2010s, and it was meant to be lightweight, portable, security sandboxed by default. And here's the thing, all of these things are good for a browser, but they're really great for the server side and to be serverless. Now,
which coincidentally is what Fermi works on. Wow, what a lucky coincidence.
To run on a server, you need access to things like files, clocks, system interfaces, random number generators, and so on. And this didn't exist up until 2018-19 when something called WASI was introduced. This stands for WebAssembly Systems Interface, and this essentially allows you to run WebAssembly outside a browser. So you don't need a browser anymore to do all of the cool things WebAssembly is capable for. It gives you access to files, file systems, clocks, and random numbers, completely independent of a browser or a runtime that is on the browser. And it extends WASM's security sandbox to include input-output. So for a WASM file to work with another file, you have to explicitly give it permissions to get access to that file because it is security sandboxed by default. How essentially WASM works, very simplified, is you write code in any language, right? Python, JavaScript, Go, Rust, whatever.
No.
That is compiled using an SDK such as Spin to a WASM file. Now, this WASM file can run in any platform, any architecture, any operating system, as long as it runs a WebAssembly runtime. So in this case, maybe WASM time. Think of it as sort of a virtual machine, right? But just that it's independent of platforms, architectures, and so on. And that's how WebAssembly becomes portable. Okay. You can write code in all of these languages and run it anywhere. So for something like this to work, you have to think of the contract between operations and a developer as it is right now, especially in the case of writing serverless apps. What it looks like is you have a proprietary software like Azure Functions, AWS Lambda, Google Functions, and so on. And your function either lives in Azure and your entire microservices architecture lives in Azure. And typically, your Azure function will not work with your AWS Lambda serverless function, right? You are locked into something like an Azure. Or at a slightly low level, you have a container and you have container registries such as OCI, or maybe you're in the Kubernetes ecosystem, or you have an app running on a virtual machine. Really, we are seeing a future where there's something called a component model, where essentially everyone is writing certain components that do very specific tasks, which all can work with each other regardless of the language that they're actually written in. So going back to that example, you can write code in whatever language you want. You can actually use libraries from all over without knowing what the other language really is, because of how WebAssembly works. And essentially, WebAssembly takes care of the rest. Again, this blows my mind, so I hope it's blowing your mind as well.
It is. It is totally blowing my mind. Thank you, dude. So yeah, they really are speedrunning, reinventing the executable model kind of stuff, but in a worse way. Not to say that the pre-existing stuff is perfect. It is definitely not. But this is not better at all. So do get ready. Get ready for the Python date library sneaking into your WebAssembly thing. This is so bad. Why is it like this? Why are these people doing this? You see, here's where you get to the worst part of any marketing related thing. Ultimately, a company sets out to build something. That something might be good, might not be good. Obviously, it's not like you have an universally objective way of evaluating if something is good or not. Is Zig good or not? Obviously, some people will argue that it is good, but ultimately, we don't exactly know. And same with other technologies. But at the same time, there are, like, it's not that hard to find that sometimes certain things are just bad. But the company is doing that. That's their business now. And so the only thing you can do is, all the people involved with that company are basically required to say good things about it. And I don't know, man. I don't know. I don't want my JS app to depend on a fucking Python datetime library. I don't want Python in my WebAssembly, man.
Imagine writing a JavaScript app, but using a YAML parser that's written in Rust and using a date formatter that's written in Python.
Which you can, by the way, you can already interoperate. That's what low-level or general-purpose programming languages give you. That's what they already do. It's already possible. And you have absolutely rational reasons to not want to have high-level programming languages sneak down into these low-level fundamental things. And also, like, yeah, you can totally automatically use a Python datetime library from another language. You don't even have to care about it, for sure. I totally buy it. It's not like Python is going to have, like, for example, I don't know, exceptions which don't exist in your language, which then will require all kinds of jankiness to make that stuff work. This thing is absolutely insane. These people are basically, with all due respect, I feel like that these companies are basically fighting over the same turf that basically Docker won over in the past. They're kind of trying to basically replace Docker, right? As creating these platforms for like being an all-encompassing system to do all kinds of development. But as they do so, they do it in such shitty ways. So no, man, I don't want a Python WebAssembly component. Thank you very fucking much. Wasm can't run as fast as Java JVM, and it can't replace JS. Right now, Wasm depends on the JS namespace to access and manipulate them. Yeah. I guess the final game is making browser really a true virtual OS for all platforms. No, guys. They are not. These people are not really concerned with the browser much. The browser is not where their fight is. Their fight is the backend. They are trying to replace Docker. This is actually, honestly, not even really that surprising. Like, I think that, I don't know, to me, and not just me, but me and also all the people that I talked to, it became clear, like, I don't know, it's been a few years since it became clear that basically WebAssembly is shaping up to become the Docker killer. They want to kill containers using WebAssembly. A lot of companies are basically trying to achieve the same type of thing that today is achieved via Docker, but instead use WebAssembly. These people used to be a sponsor of Zig. I said these people, and then I'm blanking on their name, on their company name. I don't know. Let me see. WASM serverless. What shows up? Fermion, of course. WASM Edge. No. CNCF, Fermion, WASM Labs. It's the people who made WASX. Written like this. Sorry, WASX, I guess I should say. WASX. I forget the name of these people. Oh, it's Wasmer? Oh, yeah, you're right. It's Wasmer. Why did I have an S in mind? But in any case, like Wasmer, for example, had these blog posts where basically they let me see if we can find it. Py2 WASM, a Python to WASM compiler. Zoom, of course. Hey, Fubar Quicks. Thank you for hanging out. So Wasmer has a Python to WASM compiler now. Who would have thought that? Wasmer JS XDK Onyx, new programming language powered by WebAssembly. Wait, why is this here? Do they have anything to do with it? No, they don't. Wait. Where's their blog thing? Show me the post list. Winter.js. They had a blog post. Man, the fact that as I scroll down, it keeps adding new blog posts, but making them like they're all shifting place. It's driving me fucking insane, man. So there was one blog post that I forget the title of, where they're showing one thing that they like, one feature that Wasmer supercharges blockchain. Awesome. Wasmer and trademarks extended. Oh god, man, no, come on. So I can't find that blog post that I was thinking of, but they have a blog post where they even show something like this, where basically their idea is, oh my god, and now it's falling all into place now that I think about it. Their idea was, you take you write an application, but you target, and when you write that application, you target WebAssembly plus WASI. So if you need to do file access, you use an interface that is the WASI interface. So your output is a WASM file that expects a WASI environment around it. Then what they were going to do is take your WASM executable and translate it to native code. So they were taking the VM bytecode, and then they were compiling it to native machine code. And the idea was that what the feature that they were pointing out, like the gain from doing stuff like this, was that native code is faster than interpreting WebAssembly. Yes. So, and also they were able to compile. They were working on a compiler that would take WASM and turn it into, and that was able to compile WASM down to different architectures. So they were saying, yes, and by doing this, using this system, you can have then your WASM, we can make your WASM blob turn into a native ARM Linux executable, into a native ARM Windows executable, for example, with the only, and they could do it because they could also, since you were also, how can I say, for I/O, you were targeting WASI. What they could do is also add some shims around your WASI interface to make your WASI file accesses and etc. work for all these specific targets, all these specific OSs. So basically, they were achieving cross-compilation and portability, but with extra steps. What in Zig you do directly. Is the article at the center of my screen? You think so? Which one? Oh, universal binary format, you mean? No, that's part 2. Oh no, I clicked the wrong thing. Can you tell me what you think the article was? Like the title? Yeah, you're right. This is it. Yes. Yeah, you write whatever code, write WebAssembly, then you run wasm create exe and you get standalone executables. And it's like, and you know what? By the way, we don't talk with these people anymore. We kind of burn bridges. They were very shitty people. But what I find, capture image, what does that mean? Oh my God. So you know what's funny about this? It's like, this is insulting. This is insulting. Like Zig doesn't need to go through this shit to do this. If you're using Zig, you get to the final destination without having to go through fucking WebAssembly and Wasmer. All these companies, they are proposing to you solutions with extra steps in the middle, solutions to problems you shouldn't have in the first place. You should have your toolchain, your native language thing, to be able to give you these final results without jumping through hoops. But no, they instead offer you this solution. Like, this is stupid. Like, if you're writing Zig and then compiling to WebAssembly and then feeding it to Wasmer so that it can give you a Linux x86-64 standalone executable, you're doing it wrong. Like, you're completely misusing Zig. So, I don't know, man. Right, and now I remember why I remember SY, because Cyrus is the name of the guy. So, yeah, it's the middleman stuff, right? You also have these outside of technology. You do have oftentimes people who just do everything that they can to like add as much middleman as they can so that everybody can get a piece of the pie. And then most of the middlemen don't do anything useful. That's their fucking business model. I don't know, man. Rust doesn't need the middleman either. Well, about that. It does need somebody that isn't Rust, though, because Rust doesn't compile C and C++, and also Rust depends on a libc. So somebody needs to, compile and link against the correct libc for the target system. So Rust, unfortunately, is not. It's not. I'm sorry, unequal to Zig in this context. For example, if take a look at this cargo Zig build. So the problem is, people were talking earlier about lambdas and similar stuff. You want to write a lambda in Rust and deploy it on AWS Lambda. Well, the machine that runs the AWS Lambda will have to invoke your Lambda function written in Rust as native code, right? And you will need to use the C standard library in your Rust code because that's how Rust works. Rust has to use glibc or some libc. Zig doesn't have to. Rust explicitly decided to always depend on a libc. Problem is, if you compile your Lambda on your machine, your local Rust compiler will fetch from your system your local C library. If it's the same as the one on AWS, you're good. But if it's not the same, you will have trouble. And the problem is that the machines run by AWS, they don't get updated every other day. So it is not uncommon for environments like Lambda or some other server environments to have pretty, fairly dated glibcs running around. So the only way that you can guarantee that you're not going to have a bad time, because on paper, you should be able to target a newer glibc and still run that executable on an older glibc, but it doesn't always work correctly. So the only way you can pull that off is by either using a Docker container that has the same version of the OS. So you spin up a Docker container that has the same version of glibc and the same environment as the as AWS servers, compile your Rust Lambda in there, and then take that executable, like that final blob, and send that to AWS. Or if you want to avoid Docker, then you can use Cargo Zig build. In Cargo Zig build, it's basically going to use Zig as the C compiler to select the correct glibc version or Muscle or whatever that you want. So no, unfortunately, Rust doesn't fully solve that problem, which is, if you think about it, interesting, because it is a systems programming language, but at the same time, it's not as Zig in that sense. I would argue it's not as general purpose. But I don't know. I guess there are different ways in which you could look at it. Man, what a story. Whew. Let me go get something to drink. I'll be right back.
Without really knowing how to write Rust or Python, or honestly, without.
Also, by the way, while this thing is comparable with what we're already doing, it's not like the current situation is perfect. It's not like, for example, somebody writing Python is perfectly happy to have a C dependency in their project. Because, well, they should be somewhat happy, because if that thing is doing intensive computation, it's better to do it in native code than in Python. But also you do have the problem that, if you get an error, if you get misbehavior, if you're trying to understand how your dependency works and you only know Python, then your C dependency is going to be kind of like a black box to you. You're not going to be able to understand what's going on in there and why it's not working how you expect it to work. And that is super annoying. So dependencies in another language tend to be annoying. But it's not like this model is going to be all that good either. It's not like the JS, the person writing the JS application is going to be happy to have to look at Python code. You could still argue that it's easier to look at Python code than it is to look at C code, which I'm not sure I would even all agree all that much, depending on how funky is the Python code. I would agree, though, with C++. I would agree that it's easier to look at a Python application than a C++ one, dramatically so. But still, it's like you're not even solving all those problems. So I don't know. This is like yet another situation where they're working hard to enable middlemen to sneak into a process, into a system. Can you put debug info in WASM? Yes, you can. I believe that there are two mechanisms. One is that you can literally output to dwarf. So yeah, you can output dwarf. And I think that there's another thing called source maps that also I think work with WASM, but I don't know anything about those. I believe that Zig outputs dwarf for WASM, so you can totally get a stack trace. Like if you want to look at the new implementation of Autodoc by Andrew, which runs in WebAssembly on the client, that one even like it leverages dwarf information, and you're able to step from the JavaScript into the Zig code and back, and it works.
Without even caring that it is written in Rust or Python. As long as your YAML is parsed and your date is formatted the way it's supposed to be, your JS app will run. That's what the component model unlocks. Essentially, any WASM server-side app or any WASM app.
Hey, are you tired of having only one runtime in your WASM blob? How about we put the Go runtime and the Python runtime and the JavaScript runtime, and we put all of these runtimes in just one WASM blob? What do you say about that?
Is made up of WebAssembly modules. Now, these can be written in things like Rust, Go, C++, and many more, and they're compiled to a core WASM module. Each of these modules are portable because we said it can run anywhere. the binary size is very small, so you're saving on money and you're saving on carbon footprint as well.
Super small.
And
you're saving on everything.
It's isolated by default. It has very fast startup times and no cold starts. These are completely open standards, so you can run it anywhere. With this recent launch of the component model, one of these modules can work with another almost seamlessly, right? In a way that you can compose applications. So you see component A.wasm, which is a core wasm module on your left, and you see component B.wasm, a core wasm module on the right. Now, one can export the thing it does, and the other can import the thing it wants. And this way, you can write it again in Rust and Go, and really have them work against, or rather work with each other to create a new component in this case, which is component C. And you can see that.
Can wasm blob talk to each other? Say you have a game engine that wants to support user scripting in managed code and then allow them to reference code written by other users. I think that's a good question. I think you would have to load all the different blobs in the runtime, and the runtime would have to basically satisfy all the exports, or rather, sorry, all the imports. So it would have to take all the exports from the various blobs and try to satisfy the imports. You know what? It's a linking problem. Basically, what you're asking is, can you do linking with WASM? I'll tell you one thing. You can do linking already with normal executables. So these guys have to reinvent linking, basically. But I would argue that, yes, it should work. What the component models does is, the problem, though, is that while you can connect WASM blobs together, the types that you can only speak in terms of when defining these things is very low level. Like, you can basically only talk in terms of, like, I think integers and floats. You can't talk in terms, like, you cannot say, oh, this struct accepts, this function accepts a struct with these fields. Right now, WebAssembly doesn't allow you to do that. The only thing that WebAssembly allows you to do is pass around numbers that then can be interpreted as pointers. And so when a function wants to access a given value, they know that the number that they were given is an offset inside memory somewhere. And so they can go there and accept to find the bytes in the right order that they expect them. And that is the unfortunate problem, that if you look at a function signature, then you're not going to be able to know if both modules agree on what should be stored at that location. So you cannot look at the signature and guarantee that both expect the struct at that location to have the same shape. And that's what component model is trying to solve, plus a ton of bullshit around it.
Stack-like thing in white next to the WebAssembly logo, that is actually your memory. As you can see, your export and your import is not really interacting with the thing that your business logic is working on. So because this is the security sandboxed by default, we're actually creating interfaces for each component so that they can talk to other components in the WebAssembly ecosystem. That's what the component model really is. Here is an example of how this would look like in production. On your right, you can actually see on the top, there's something that says business logic component, and there is an export. And this business logic is the logic you as a developer, right? Now, maybe you want to have authentication and authorization for this business logic, but you don't want to write it from scratch again. So you can actually use a component that does auth for you. So here is in the middle, an auth middleware.
Oh man, I can't wait to use the brainfuck authentication middleware.
Component, right? And you can actually see that it exports and it imports. Basically, there is an interface for it to talk to your business logic. And then at the very bottom, you have your WebAssembly or your WASI HTTP implementation, which could be either on Spin, on Wasm Time, on Nginx Unit, Wasm Cloud, and so on. Essentially, you can see how these different components are independent components of each other, but they are working with one another. So if you're writing business logic and you want an auth middleware component, you can go ahead and do so. all you need to know is that it exports and imports, and that's how it interfaces with another component. In fact, here is...
Yeah, I think this explanation is really burying the lead. I think the core problem is because, like, the fact that you already have an export and an import, it means that you need to specify some kind of signature of something. What they are trying to solve, which is not being said at all explicitly here, which is, I find very annoying, because we had to go through so much marketing bullshit and we didn't get a single technical detail. So hopefully the demo afterwards makes that more explicit. But the point is, looking at signatures doesn't tell the full story. It doesn't guarantee that the things are compatible or not. To be fair, even if they share a full type signature, that doesn't guarantee it either, because like guaranteed correct semantics goes past a type signature. No matter how complicated you make the type signature, but it is fair to say that that being able to say more than just being able to talk in terms of struct shapes could be nice, I guess. There's a, let's see, from YouTube. Is Zine up and running now? And if it is, how can I use it to build a website? A doc guide you'd recommend? So Zine is, yes, up and running. I believe that the latest version I have committed supports Zig version 0.12. Never mind, Zig 0.13. So if you have the latest tagged version of Zig, it's gonna work for you. So this is the version of Zine that you can get. The recommendation that I have is go to the official website, zine-ssg.io. So let me send that. So go to the official website, click on Get Started. Getting started will tell you to clone this repository of this same website and to run it locally. I believe that you might need to make a change because I haven't updated the website yet, because I think that the website still depends on a version of Zine. What am I doing? No, this is Zine itself. This is not the website source code. So if you go to the website source code, I haven't touched it in a while, huh? Oh, there we go. zine-ssg.io. So once you clone the Zine repository, I think you will see that this version of Zine is a little bit old. You will need to update it to latest, maybe. I will do it like in the next couple of days. But if you want to try it now, I haven't done it yet. In any case, just a little bit of work, and you will be able to run the official website on your local machine. And that's your starting point. Then you can, on the website, you can read the links. Like there's the docs section that explains you how to do things. And if you want another different example, I have also my personal blog in here. Christoph-IT, Christoph-IT/Christoph.IT. This is my personal blog. It's another Zine website. If you get stuck and need help, you can go to Discord. Join the Software You Can Love Discord. This is my Discord server. It's linked everywhere, I think. It's also linked in the community page. And what did I want to say? That in here, there's a Zine channel. And you can join the Zine channel and ask questions. So, for example, Armau was pointing out that there's a thing that they would like to have changed. So, there's discussion there. Be aware, though, I'm not lying when I say this. Zine is alpha software, and using it today means participating in its development. So be aware. Right now, the reason why I haven't touched Zine itself in a while, it's because I'm now working on the HTML parser stuff. So I'm basically down in a tiny rabbit hole, and I need to come back out of it.
A demo that I'm going to show you, and I'm going to show it to you very quickly. But you can check the entire code.
Okay, I'm gonna skip forward a little bit. Let's see.
I think it's a very cool example of how the programs in multiple it doesn't actually affect.
Okay, so it's the same middleware thing. Come on. Show me like some signatures. Conventional CI/CD.
but that also reduces your compute storage and networking on GitHub.
No, man.
Works and
okay, wait. There was some source code here at some point.
Will be a standard that you can use.
It was very brief, but I saw it.
It's not yet authorized. So I'm going to click on login. Now, when I click on login, it authorizes me to then the code. You can see different.
Oh, it's just showing
different components for
piece of code.
Authorize.
So it's not showing how the freaking interfacing actually works, right? Oh, also because the component model it's still in flux. I don't even know if you can even do anything with it for real today. Okay, so man, what a mess! Holy shit. I'm good. I feel like I'm good with WebAssembly. I don't want to hear anything about it for a while now. What a shit show, if I have to be honest. What a shit show. So here's my plan. I am going to take a 5-minute break, and then I'm gonna do some actual development work for real. So no more silly videos to watch, just coding. More specifically, the goal now is to take the HTML parser. By the way, yesterday I did some more work. Now my HTML parser and LSP doesn't crash as much. So it's more resilient. Well, it's not really resilient. It's just that there were a bunch of to-dos that I actually implemented. There's still more to-dos, but some ones that you would hate very often while typing are now okay. And so, yeah, now it's usable, maybe still a strong word. But in any case, what I'm going to do is publish it as its own repository. And then for people, if there's anybody who is interested in collaborating on a HTML parser and want to help me, be more spec compliant, and I have support for the more weirder stuff, then we can all collaborate together if you want. So give me 5 minutes, and then I'll be right back. I'm back. Okay. Whew. Let's do some software development. Let's go. Let's also have some music. Ooh. Sorry. Forgot to pull down the volume first. What kind of new Zig LSP or existing one? It's for my site generator. Yeah, it's an HTML LSP. Zig LSP, basically ZLS is already pretty much as good as you can get with a third-party implementation. Well, with a, let's say, reasonable third-party implementation. The next stage of quality for the Zig LSP will be when the Zig compiler itself will be able to expose some diagnostics. Not quite there yet, but it is on the list of things to do. As in, it's on the Zig roadmap. ZLS would be even better if it can be disabled entirely in the VS Code extension. Are you saying like on specific files? Like you have a file that makes it crash or something, and so you want to occasionally disable it? I don't know how VS Code works, but like in Helix, you can do this kind of stuff. Like in Helix, I can do it actually easily. It's just slow? Really? What kind of code base are you talking about? I really never experienced slowness from ZLS. Let me ask you a question, like a serious one. So, did you by any chance have like a checkout of ZLS on your machine? And did you Zig build it? And if you did, could it be that you forgot to do the optimized release fast? Like if you have a debug build of ZLS, yeah, I can see that potentially being slow. But if you make a release fast build, in my experience, it works. I've used it also on the Zig code base itself. Never had any problem in terms of performance. So here's what we want to do. Let's do some, like, it's basically, sorry, it's going to be somewhat boring packaging work, but it has to be done so that for people to be able to participate. Is release fast okay? I've always used release safe. I don't know how much of a difference is there between release fast and release safe. Obviously, release fast should be faster because it has a bunch of checks that are, you know, like assertions, for example, in release fast turn into optimizations. They stop being like in a release safe build, your asserts are extra code that has to run. Like each assert is an extra check that will run at runtime every single time. In release fast, not only those checks don't happen anymore, but they will also be leveraged for further optimization. So I would say that yes, you should expect release fast to be even faster. I guess the question is, are you experiencing slowness with a release safe build of ZLS? If you are, then maybe it will make a difference. If you aren't, like if your ZLS is already fast enough, it might be that the difference is going to be so small that you don't even feel it. So yeah. It's the start time it adds to VS Code really sluggish start. That's also weird. Like, I don't have first-hand experience much with VS Code, so... But man, shouldn't VS Code, like, spin up the LSP as a separate process? Like, let me tell you, that is not my experience at all using Helix. So, I'm starting to think that it might be something else, which is maybe still ZLS related. Maybe it's not ZLS the LSP. Maybe it's ZLS the VS Code extension that might be introducing some issues. But that's not my experience at all using Helix. Okay, so here's what we do. A big problem for ZLS right now is compiling the build script and FMT. I would suggest to not use ZLS for FMT. Like I don't know how it works in Visual Studio Code, but like you can set up the Zig executable to be the one providing formatting. I agree that the formatting protocol is kind of weird when an LSP is involved, but like just set up Zig FMT to do the formatting. With Helix and ZLS, it sometimes makes it so Helix is super slow to close as it's trying to close the connection to the server. Yes, that happens when the LSP crashes. When the language server crashes, then Helix will hang while waiting for it to do something that it will never do, and so it like that thing has to time out. Yeah. But I would say it's not I understand that the slowness is a problem, but it's not a performance problem at that point, right? The problem is that the language server crashed. By the way, for people that are having these problems, here's another thing that I would ask you: Are you using a up-to-date version of ZLS? I occasionally update Zig, forget to update ZLS, and then ZLS starts having issues. Then after a while, I remember that I can fix just by updating ZLS so that it becomes more so that it basically makes sense that you have a ZLS that is older than the version of Zig that you're using, and then maybe something goes wrong. FMT is now compiled on the main. If it's not in the cache, then formatting waits for Zig FMT to be compiled by LLVM. Yeah, that's a fair point. It's annoying, but it only happens once, right? I'm assuming that the Zig FMT compilation goes in global cache, and then you don't think about it anymore. Not up to date, but tag 2013. Okay. I think that you can use newer versions of ZLS and with an older version of Zig, and it will work correctly, because if I understand correctly, they have like some versioning for things. I might be wrong, or I might be right on paper, and then there might be surprises in practice, but I don't know, just letting you know. Okay, so I want to make a new repository for Super. Oh no, my muscle memory. You know what? Just so that we give Arc a fair try, remove Safari from dock for a while. Let's go full Arc. They call it Super HTML. For ZLS to resolve modules build options, sync loop paths, it needs to build and run your build.zig, which means that if it's not in cache, ZLS has to wait for LVM and meet again. Yeah, that's fair. But it doesn't have to build and run your build.zig. It only has to build it. Or rather, no, you're right. It has to run it, but it has to run it. I'm gonna say it doesn't really run the build. You probably knew this. I guess I'm saying this more for the other people watching. Yes, you have to run the build.zig script, but it's running a different runner, so it's not gonna run the build for real. It just needs to be able to inspect the build graph, which is also fair. Fuck. Okay. So let's do a couple changes here. Actually, some should require renaming. So let's move. So let's move main to root. And let's move CLI to main. Although, honestly, calling it CLI.zig is not a bad idea. I like this CLI nomenclature. You know what? I'll leave it like this, I think. So this becomes root. This becomes root. As ZigFNT is built release safe by LLVM, it's a non-trivial wait. Oh, that's annoying. I see. Well, such is life. Yeah, this is CLI. Okay. So these should be it. Let's see. Can we zig build? Oh, we depend on front matter? Really? No, this is what I want. We import it and we re-export it. As a dependency, it almost looks like it's something that we... Why do we even do this? Like, we were not using it internally. I guess we did at some point, maybe? I think we can delete all references to it. Oh god, but we do depend on scripty. So publishing this repo as its own repo requires us to also publish scripty as its own thing. We can do it, I guess. So we need to do this work. We need to also update Zig LSP kit. So let's get to a building state. Oh no, we can't because of scripty. Okay, so let's go fix Zig LSP kit, and then we come back here. Okay, so now we're pushing. And now we can go up, go into super HTML. We can do this. We can fetch this. Fetch should have updated us to the latest version. Or not. Why did he give us a hash? Oh, because it's fetch -- save. I'm dumb. Can I put it at the end? -- save? Yeah. Okay. Boom. Got a new version. Not bad. Okay, let's solve for scripty now. All right, it wants the Git protocol. Oh, but it doesn't have a zone file, so we can't do this yet. Okay, we will come back. Okay, let's see. Man, whew, Scripty doesn't have dependencies. Thank fucking God. Can we zig build? I don't know what we're zig building actually. Zig build test. Can we zig build test? Tests haven't been updated. Oh well. So that's fine. That's on me. I haven't updated certain things. Okay, that's good enough, I guess. So we can git push. Well, we can git add everything. Oh shit. Yeah, I did it wrong. Can I reset? Okay. Let's copy the git ignore over. Now that's much more reasonable. So we push. Go up. Go into super. Fetch. Can we build? No dependency name front matter. Oh, so because I didn't delete the code that it tries to add front matter as an import. Oh man, wait, was I depending on front matter because Scripty wants it actually? No, I was adding this as a dependency to myself. No, Scripty doesn't have dependencies, so we should be good. And watch me forget something, miss something, and regret what I'm doing right now. Okay, that worked. Okay. So now super is its own repository. And that means that now we can contribute to super independently. So You know what? Whatever. We can explain this stuff at a later point. Right now, the question is contributing. Let's do contributing to the HTML parser and LSP. Okay, so I think this is like the important stuff. Okay, so now we have a README. Well, let's see how it looks. Oh my god, where did I put that thing? Is this just not updated? Oh, how do you refresh a page? Yo, what happened to my README? Man. Oh, did I not get, I didn't get pushed. I'm stupid. Sorry, that's on me. Okay. There we go. The problem with readmes is that if enough people don't read them, they disappear. It's like with magic in the story of Peter Pan. Okay, so this work is done. So I guess the next question is, we want to go inside of Zine. And we want to reference things better. Although in this case it's what? Super, it's both super and scripty. Actually, do we even depend on scripty here? No, we don't. So it's just super that we need to do. Is it name? What is it? Oh, save equals name. I don't know, zig build. I'm actually not even sure what it is that I'm building when I run zig build, but okay, it seemed to work. Yeah, no worries. I just wanted to point out that the code is now out there. There in the README, there are instructions on where to find the files that are relevant to the HTML parser, because there's also all the templating stuff that right now is not relevant. And if for some reason you want to take a look at the tokenizer and you know, judge how spec compliant or not compliant it is, you can do that. And PRs are genuinely welcome. Like I want to keep working on it, but at the same time I don't feel like going through all the spec and everything else, so I would totally use some help if you're interested in lending a hand. So the next question is, that said, that's like the parser aspect of it. Then there's still also other work that I would like to start setting down to give as a framework in case that somebody else who is interested in an HTML parser can help with. And that's diagnostics. Right now, we are completely ignoring all diagnostics. And I think we shouldn't do that. I think we should instead, well, start wiring diagnostics into the LSP so that the LSP can tell us that the HTML has errors in it. But then to make those diagnostics good, we need to also maybe understand a little bit better what the spec wants us to do in terms of recovery when things go wrong. You know what? Maybe I can get started with that work, actually. Okay, so it seems that the Zine works well enough, I guess. Git status is basically that a bunch of files were deleted. It almost looks like it almost looks like this branch has done nothing other than just destroy stuff. So, well, that's what it is. Yeah, now they're all external depths. Is there a reason for the tokenizer to not have unit tests? No. The thing is, it didn't have them originally. Like Johnny's code didn't have unit tests, and I think I only added a couple at some point just to learn the API, like what to expect to get from it, just to take it for a spin, and then I deleted them. So I never had any test that felt. I never looked, since I didn't write most of it, right? I was just hammering some changes into it to make it more fit for my personal use case. I never add the unit tests to it. Sorry. That's the state of things. Okay, so yeah. Let me take a look at something though, just to make sure that we didn't break things inadvertently. Super HTML. Does still mention tree-sitter in its dependencies, right? Yeah, okay, we still depend on tree-sitter because we cannot really take out the tree-sitter dependency until we are done with our own parser work. And we have wired it into the templating system, because right now the templating, like the rest of the files, all the files outside of HTML, they're still depending on tree-sitter. So yeah. What does developer mode do? Copies links. Capture in portrait mode. Capture a portion of this page. Oh my god, capture in portrait mode is like, it allows you to create like the photo thing. Okay. Oh, there we go. Console. Network. Elements. Okay. Splits. Okay. Pull requests. Wait, how did we end up? Why was this folder created? Like, when did that happen? What happened? Okay, this browser is doing weird stuff. Okay, so this should all be good. Let's kick off diagnostics. So here's the problem with diagnostics. The main problem with diagnostics is that. So here I want to be with my, I guess here I want to do that's the HTML, I guess, with some HTML files. But then in this same folder, I want to open the editor to edit the source code. And I want to take a look at, we start with the tokenizer, I guess. Well, no, we should start with the token. Yeah. Okay, let's add support for one type of diagnostic. Let's just do one to kick it off. Or you know what? We don't do it in the tokenizer because that will require some more work. Let's add better support for one of these guys. So for one of the errors created from here. So let's make this range. Let's call it span. Let's make it optional. Defaults to null. And we can say this. To do. This is optional. Only tempo. Oh. Okay, so we make it optional just so that we don't put undefined in there with random shitty data. Parse error. We omit this stuff because it's all undefined, but EOF in tag, missing attribute value, blah, blah, blah. And this is all fine, but there's another one, right? Where we see an end tag, but the end tag doesn't match anything. So what do we do there? Where is it? Append spurious end tag, range ET name. Perfect. I think that it shouldn't even be ET name. Problem is, oh, we are observing this error before we see the right curly. Well, the right diamond. Okay, so this is fine, I guess, for now. Okay, so this error has a range that we can use. So this is one good type of diagnostic that we already, well, a good type of error that we already produce. We just need to have the LSP report it when we encounter it. So we look at the LSP and we want to look at well, we look at LSP and we look at the one where we could be reporting errors. Which is it? I think it's open file that is able to report diagnostics. Yeah, open file, change document, or more in general, whenever we do load file, I think those are the cases where we could be doing diagnostics. Because I don't think there is an explicit request for diagnostics. Yeah. Okay, so let me very briefly take a look at how I do this here. So when we load a file, here we initialize something that could hold diagnostics. Then we parse it and we set the diagnostic values. And then we call send client notification with the diagnostics as we're done loading the thing. Okay, let's do the same thing also here then. Load file. Oh yeah, we actually did have this already. But our diagnostics were always hard-coded as empty. Right. Which is correct, because you want to send an empty set of diagnostics when you don't have any, because there might be still some diagnostics active from the like they don't disappear automatically. You have to turn them off, and sending empty diagnostics is a way of turning them off. Okay, so what we want to do is if doc dot ast dot errors there are more than 0 errors, then we want to do, or you know what, doesn't even have to be an if, right? It can be like a for loop. No, but we want an if because it involves dynamic allocation. So if there are any, then we need to make just as many diagnostic slots, I guess. Let's make an array list for now. Diagnostic. Okay, here we have our diagnostic list, and we want to append to it. I guess we want to do this for each error. If it has a location, then we generate that error. If there is a function that accepts alloc to do some stuff and return result in buffer allocated using alloc. Oh god. If there is a function that accepts an allocator to do some stuff, yes, and at the end it returns a result that is a buffer allocated using that allocator, but also uses the allocator to allocate some temporary space to do processing, and it frees it before returning. Does it mean the passing arena to get the result, and if I pass an arena and get the result, it won't free it for a long time and it will leak memory? Yes. Is it a problem with the function or what? So if you have a function that uses one allocator both to save temporary state and also to allocate space for a final answer, and you pass in a arena allocator to that function, yes, that function will try to free memory that it temporary memory that it used, and the free operation will do nothing. So you will leak, not exactly leak, but yeah, it will stay there for longer than you that memory will stay there for longer than you intended for it to stay. How can you prevent that? In my suggestion, what you should do is pass in maybe 2 allocators. One explicitly named arena for temporary things, and one called GPA for long-lived data. This API here of the LSP server, for example, for every request passes in an arena allocator that will be reset automatically by the LSP server as soon as your request reply loop cycle has been completed. So my suggestion is, don't call arena the implementation. Call the allocator interface parameter arena, so that you can suggest that this allocator is expected to be used as a temporary scratch pad, and call GPA instead a second allocator. So literally do this. Give to a function this. If you think that it makes sense for a function, like if a function both has throwaway things and it has long-lived allocations, do this. It's not a bad idea. Oops, I only want to delete the bottom one. Right. Oh man, there's another problem here. We need to transform a byte offset into a line and column position. Oh man. Right. I feel uncertain about using JSON parsing in Zig because as it uses Arena internally. If I understand you correctly, if JSON parsing accepts only one alloc, it won't leak memory. The JSON parser in the Zig standard library expects you to pass in a GPA, and it will create an arena out of your GPA if you use the normal parsing function, the non-leaky parsing function. So yeah, the JSON parser wants a GPA, period. It's something specific to that implementation. That's how it wants you to do things. I mean, if you pass an arena, it's not like it's the end of the world, but it works off of the assumption that you pass it at GPA. And I don't know if it allocates. I think it does allocate with the GPA temporarily. Yeah, I think it does. But then the arena that it creates is it's like, let's just say that it creates like the result. It's like bundled inside the tiny arena. So, oh man, I can try to explain why it does that. It's just a little bit long to explain that. But long story short, you can give a GPA to the JSON parser and it's fine. If you happen to only have an arena available to you and you want to do some JSON parsing, you can use, for example, parse leaky. That's another thing that you can do. If you use parse leaky, the JSON parser will not create another arena. Okay, now I have to figure out this goddamn byte offset to line and column number thing. I think that ZLS has some utility that does this. I think they do have that. But I also think that I implemented it myself in the other one. Let's see how I do this in Ziggy. Yeah, I have get error selection, don't I? Oh, it's pre-computed. Right. It's pre-computed. I'm losing steam. I'm so tired. I guess the tokenizer knows how to do this stuff. Yeah, get selection. Ah, man. I guess I'm gonna temporarily place it here. Wait, do I not have any? Do we not reference anything specific to Super HTML AST? Okay, so it's Super HTML stuff. Oh, diagnostic is not defined inside of here, right? Uh-oh. The range. Okay, so this returns a range. Ooh, man. Okay. Oh, I'm returning a range, so I can do just range. Let's just call it this get range. Okay. So get range. Okay, the things here are not line call start. They are like, yes, it is start, but I think it's something else, right? It's not line and call. Line and character. Okay. So this should be kind of doing what we need to do. So it creates a diagnostic in case that something matches, and then we do res dot diagnostics equals doc dot no dag list dot items. There we go. That should be it. Well, we need to actually see if it compiles or not, but we're getting closer. Zig build. Let's see what the error is. Pointless discard. Oh, we're not using the arena, and now we are. Let's go. Okay, next problem. Range. No filling range. Okay, this is in AST. Spurious end tag. Oh, there are two places where we call this spurious end tag. But what's it called? Span, right? Okay, we built. That is interesting. Okay, let's tail the... Oh, I was tailing it already here. Right. So we don't need to do this. Okay, we're tailing the LSP. Oh, we're not invoking the LSP. What's going on? Oh, shit. Right. Okay. There we go. Now we're invoking it. Ooh, and with just this, it crashes. To do implement invalid first character of tag name. This error is not implemented. That's annoying. But we can. It's fine. This is not the error they want to test. They want to test for. So let's restart the LSP. And it works. It's auto formatting. Now let's introduce an error. Oh, god damn it. Okay. So we're good. What happens if I now paste this? Reach an unreachable code. Assert current and close equals 0. Huh. Do I still get this error if I restart? Yeah. So this situation causes a bug. Quick question. For the HTML parser, are you planning to only support normal and void elements? There are actually 4 more types. No, I would be open to support more than those. So I know there are self-closing elements for other things that you can embed in the HTML. So that would be a third type that I'm aware of, and I want to support that. And there's what, the CData bullshit type of thing, other XML bullshit. Like in general, I would be open to add support for those, yes. Although I believe that, like, for self-closing elements, for example, we would need a specific list, right, of which are the elements that are able to self-close. Is that correct? Basically, row and escapable row. Oh, so we're talking about something else. Let me think about it for a moment. So basically, row, style, and script. Text header and title. How can you read logs from the LSP? Is it just reading logs in file and reading from file using tail something? Yes, that's what I'm doing. I'm writing to a file inside inside the cache. That list is on the spec. So, okay, I see. So I would say, well, setting aside the weird other XML-ish, other, you know what? Ultimately, I feel like XML and CData, weird shit, that's not, I think it makes sense to support it, but it's not high priority. Supporting title, text area, style, and script tags, yeah, that is more important. Totally more important. If you look at the tokenizer, so if you look at Johnny's tokenizer, it has been written following the spec, the HTML spec somewhat. It's not following it to a T, but it is yeah, but it is how can I say, it's inspired by it. Well, more than inspired. He's doing a lot of the same things that the spec wanted him to do. So hopefully adding support for other things that you are describing shouldn't be too traumatic, because it should still be roughly the same state machine. Okay, so let me chase this error. So basically, I have an assertion. I have what I thought was a invariant that turns out is actually pretty variant after all. So let's take a look. Here we go. 226, yeah. So we're finding a end tag our bracket. Okay, let me toggle this off temporarily just to see how that works. Oh, there we go. We get spurious tag, except the counts are wrong. So the location is wrong. We do get spurious end tag. It's just pointing at the wrong place. Let's try to fix this. I may need to do the -1 stuff that I was doing in the other thing. So we can start at 0, 0 maybe. Let's see if that helps. Better. But it's still... It's still slightly off. But we got the beginning of diagnostics. And I called it spurious, but I think other people call this erroneous. I think that 3-seater uses erroneous. So I'll go with that. Oh, this is Ziggy, right. Let's go with erroneous. There we go. So we have the beginning of some error reporting in the LSP. And it's actually very straightforward to add more. You just need to have the tokenizer. The biggest problem right now, why I can't easily wire in all the other errors, is because the tokenizer is designed to return errors whenever a bad token is found. But it doesn't bother keeping track of where the error is exactly, like which range of bytes are we talking about. And that is kind of important for tooling, because if you want the tooling to be able to give you a diagnostic in the right place, then you need to keep track of that information. So that is also something that needs to be done. But with this, we have added another tiny piece of machinery to our LSP, and like one step closer to making it real. So I'm gonna push these changes so that people can play with it, with them, and I'm gonna call it a day. Okay. So that's it. That's it for the stream. I hope that people have fun. So, oh no, X2, I'm sorry. Yeah, it is, man. It's already late for me. I'm tired. I was actually tired as soon as I started, and I'm ultra tired now. But we got stuff. Oh, you know what I should do? One last thing. Where will it log on Windows? Good question. I actually don't know. It is using XDG stuff, so or like it's using was it known folders from Felix. So I would expect that it has something equivalent for Windows. I just don't know what that is. Well, you can trace it. I traced C and Zig Hello World, and it turns out Zig made less URC calls. Interesting. Okay, so hopefully I gave also enough instructions to people to be interesting. Is that, oh god, I probably committed a file that I shouldn't have committed. In any case, so this is how this is where we're at right now. It's not bad though. It's not bad, right? We're have the beginning of a respectable LSP in my opinion. And frankly, it shouldn't be all that hard to make it good. It's just a matter of covering more of the damn HTML spec, wiring more errors, more diagnostics. The auto formatting behavior is mostly there, like the logic and right, the for people who weren't here the other days. So check this out. You can now do this. Let me keep this open so we can see if there are crashes. So here's the idea. If you want to split attributes on multiple lines, you add a space here, and then never mind, you watch it crash. Oh, sorry, auto formatting is not gonna run as long as there are errors, so you also need to get rid of errors. So you save, and on save you get the auto formatting. If you want to restore horizontal alignment, you do this. If you have sorry, this is a code path where we're still hitting it to do. So unfortunately, sometimes typing hits one of those things. Span. So span who. So if you have two tags, let me restart the LSP. So if you have two tags like this, they will not be split, but if you put a space, then they will be, vertical alignment will be prioritized, and same with the inside. Having a space between the opening tag and the content means that you're requesting vertical alignment. Removing it means that you're requesting a tight fit, tightly coupled tags, whatever. And that also applies at other levels. So you can do this. Let me restart the LSP because, okay, now this works. But if I pull in this tag very close, then it pulls in also this tag very close. But unfortunately, it's not allowed to remove this white space completely. Although, you know what it should do though? Wait, why is it not? I think we should basically change this white space to just be a space then. Like if there is any new line, I'm thinking that if we are in this situation, maybe we should just do this. In any case, barring some minor things that might require more design work, the main auto formatter behavior is there, and it's nice. I think it's pretty good. So yeah, I think we are like going forwards and a good direction. You can remove the last white space after text if there is no white space before text. You can remove last white space after text if there is no white space before text. Yes, it does remove that. Which I agree can be annoying. But those things where like you have all these tags that have like some space on one side and not the other, they are problematic and weird. So it's the idea is that you kind of don't do that kind of stuff. And if you really have to, you can do ampersand, what is it? Non-breaking space, that kind of thing, if you really want to get some space in a weird way. Also, you can also put spaces between tags. So long story short, I agree that there are some configurations of HTML that you're kind of changing by applying this logic, but at the same time, I would say it's not terribly foot gunny. We are not doing any big change that should take you horribly by surprise. Because I feel like you don't really have to do those weird things where a tag is not connected on one side and then connected on the other. It's like, it should be fine, I think. You know what? We need to test drive it more. I should try to write some HTML with this LSP on and see how I like it. But for now, it seems promising. So yeah, this is the state of things. I hope people have fun, and I think I'll see you the next time. I don't think I am going to raid anybody. I'm sorry. Another day, another lazy day where I'm not raiding anybody. So take care, and I'll see you next time. Bye all.